Akshaya, is my voice and the video clear? Musina Newman, is the audio clear? Okay. So if you have any doubts, you can ask me. We will start the session from 5 o'clock. Till then, if you have doubts, you ask. Guys, if you have any doubts regarding yesterday's class, you can ask me. Yeah, Dhana Sriram.
Hello, sir.
What is your doubt?
So whether a free variable can have a value 0, sir?
Yes, it can have any. It can have 0.
Okay, sir. Thank you.
It can be negative. It can be positive. It can be anything.
Okay, sir.
Munir Hussain.
Hello, sir.
Yes, Munir. What is your doubt?
Sir, my doubt is from that conditions of consistency.
Okay.
Sir, there are so many conditions, right? If any one of those conditions are satisfied, we can
Yes.
confirm that it is consistent.
Yes, those are actually equivalent statements. If you read that statement properly, you'll understand. Each of the following is equivalent. Any one is true, it is consistent.
So if one is true and another one is false, that's also not possible, right?
Not possible. When I say equivalent, they all mean the same.
Uh, okay, sir. Okay, sir.
Aditya Deshpande, what is your doubt?
Hello, sir. About the same statement, sir, the fourth one. If B is a combination of basic column of A, then it is consistent.
Okay, okay. Actually, I did not verify that.
Okay, sir.
Can you just message me? I'll just verify it and let you know.
Okay, sir.
Okay, I forgot it. Okay, so give me some time.
Okay, sir.
Yesterday
Thank
you
you.
were saying about example 2, na?
Yes, sir.
Yeah, I'll verify it and I'll let you know. I forgot it.
Okay, sir. Thank you, sir.
Pravalika, what is your doubt?
Sir, how to do verification process, sir?
Verification
In
of what?
problem number 13, the verification process, how to do, sir?
Problem number 13. Okay. See, we have written that k equal to 1, correct?
Yes,
See
sir.
here, I have taken k equal to 1. I have taken k equal to 1 by reading the options actually. When I put k equal to 1, and can you give me an augmented matrix? Here it is 1, no? K means 1. Y coefficient is 1. Z coefficient is 1. So I've written all ones here. Okay.
Okay, sir.
Using this row, you can make this and this entirely 0.
0. Yes, sir.
So rank of A and rank of AB are equal to 1.
1.
Okay.
Yes,
So
sir.
It is eliminated because rank of A equal to rank of AB equal to 1 means number of variables are 3, free variables are 2. With 2 free variables, you don't get unique solution, you get infinitely many solutions. Hello?
Yes, sir.
See, rank of A equal to rank of AB equal to 1, correct?
Yes, sir.
Free variable, the variables here, n is 3 actually, because x, y, z are there, na? N is 3.
Okay, sir.
R is 1.
Yes, sir. It is 2. Rank of
See, rank of A equal to rank of AB equal to 1. That is clear. Number of
yes,
variables are 3. We need to find
Yes.
number of free variables. Number of free variables is n minus r.
is 2, sir.
2. That means there are 2 free variables which will lead to infinitely many solutions.
Yes, sir.
What we want is unique solution.
Unique means we should get equal both the sides, right hand side and left hand side.
Rank of A equal to rank of AB equal to 3 we need to get. Rank of A rank should be equal to rank of AB should be equal to number of unknowns. Then you will get unique solution.
Okay.
It looks like you got confused. If you still have doubt, you can talk to me. Tell us your doubt. Hello?
Sir, yes, sir. In the next
If you are
verification,
silent, you will not learn anything. Yeah. So now what I'm saying is, if you take k equal to 1, this is actually not giving us unique solution. So k equal to 1 is eliminated, correct?
yes, sir.
So what we have eliminated, A and C we have eliminated. A is gone, C is gone.
Yes, sir.
Now
Next in verification.
next verification, like we have just confirmed about k should not be 1, so we have eliminated that now.
Yes, sir.
So next verification for that, I wrote again the argument matrix.
Yes, sir.
From here I wrote the argument matrix, and then I'm just doing this. R3 is R3 plus R1 plus R2. So 1 plus 1 plus k is k plus 2.
Yes, sir.
1 plus k plus 1 is again k plus 2.
Yes,
K
sir.
plus 1 plus 1 is again k plus 2.
Yes, sir.
Whereas 1 plus 1 plus 1
3.
is 3. That's what is written here.
Yes, sir.
Okay. Now, if k is minus 2, what happens? I want to verify.
Yes, sir.
If k is minus 2, you will have 0 here. So I'll write it here. 0, 0, 0, 3. If you have a row like this, then that system is not consistent, first of all.
Yes, sir. Yes, sir. I understood, sir.
Unique solution. So you can also eliminate k equal to minus 2 option also.
Yes, sir.
So k equal to minus 2 option is D. So you can eliminate that. The only option that is left over is B.
Okay, sir.
Okay. So I'll take one more doubt, and after that, no more doubts. I'll continue this class. And next doubt session would be after the class. Once I complete the concepts, you can ask me. Debadish, what is your doubt? This is the last doubt. Debadish?
Yes, sir. Sir, my doubt was also related to question number 2. Actually, one student asked yesterday, sir, whether we could express B as a combination of all the columns or for only the basic columns.
I'll let you know about that, okay?
Okay, sir. Sure, sure.
Yeah.
Thank you.
Shankar, what is your doubt? Shankar?
Hello.
Yes, what is your doubt?
While doing the elementary operations, for finding the equal matrix, if we get some numerical errors may occur, and is there any way to find that the equal matrix is that of the parametrics? Any way to
Okay.
check, verify?
Wait. Your doubt is not clear. Can you repeat what you said while converting the given matrix to row echelon form? What you
Yeah.
you say it again?
So sometimes there may get numerical errors occurs while doing.
Numerical error. What do you mean by numerical error?
While adding, or is there any mistake happens and we are getting in the row echelon form, and is there any way to verify that the equivalent
Here,
matrix
see, no. If you do some calculation mistake, then it's like you are responsible for that. No one can help you.
okay.
So you have to take care about that. Okay. So yeah. So now what I'll do is I'll lower all the hands. So the class goes like this. 5 to 7, we will have a discussion. Okay. I'll be teaching you. Next, I'll give you 10 to 15 minutes of break. And again, till 9, I'll conduct the class. From 9 onwards, you can ask me the doubts. You can ask up to 10 p.m. Okay, so wherever you get some doubt, what you do is you write it. Page number you write. What doubt you get, you write. Okay. Neeraj Mittal, if you are unable to download, what you can do is you can mail me. I can help you. I'll forward you the notes. You can even ask your friends. Okay, I'll see this text doubts after the class. So let me now continue. Shankar Jaiswal, I can understand that, but you have to make sure your mic and everything is working. Okay. Okay, so now yesterday, if you carefully see, we have discussed how to deal with system of linear equations. Today, what we will do is we will continue with the matrix algebra. So just show you what are the things to be discussed in today's class. See here, yesterday I said in matrix algebra, we will talk about addition of matrices, multiplication of matrices, types of matrices, determinants, inverse, rank of a matrix. So today, the most of the time the discussion would revolve around these topics. So let's go ahead. Types of matrices you are already aware of. I'll try to put the most important points in front of you. Let's see what is an idempotent matrix. An idempotent matrix is a matrix which when multiplied by itself yields itself. That means if you multiply a matrix with itself and if this gives you again A, right? So what does this mean? A square is giving you again what? A. Any matrix satisfying such property is called idempotent matrix. So this is the condition for idempotent matrix. What's the condition? A square equal to A. So I'll just write it again. Any matrix satisfying A square equal to A would be called idempotent matrix. Let's look at what could be the condition for involutory matrix. Involutory matrix. Any matrix satisfying this particular property, that is A square equal to I. What does I stand for here? I means identity matrix. So what does I stand for? I means identity matrix. Right? If A square gives you I, then such a matrix called A would be called involutory matrix. The next one is nilpotent matrix. A nilpotent matrix is a square matrix n such that n power k is a null matrix for some integer k. Then smallest such k is called degree or index of n. So I'll just try to explain you. So let's say we have a matrix which is non-zero. That means you have a matrix called n, which is non-zero matrix. There are some elements which are non-zero. What you have done is you have calculated n square. Let's say this is not equal to null matrix. This is also not equal to null matrix, but you found that n cube was a null matrix, right? If n cube is null, then n power 4 is also null, n power 5 is also null, and so on, right? Now you can see that n is not equal to 0, n square is not equal to 0, but n cube onwards, right? N power 3 0, n power 4 0, n power 5 0, and so on, right? So such a matrix n is referred as nilpotent matrix. So nilpotent matrix. So you can say n is, this is just an example, okay? Example, n is nilpotent matrix of, let's say, degree 3 here. Degree 3. What you need is, you just need some awareness. What is nilpotent? What is involutory? What is idempotent? Basic idea you need. Don't think too much about this. The most important one of all the types of matrices is orthogonal matrix. In 2021 also, there was a direct question on orthogonal matrix. Let's see what would be the condition for orthogonal matrix. A square matrix. Okay, so let me write this as square matrix. It's not m cross n. It has to be n cross n. It's typing mistake here. So a square matrix A is said to be an orthogonal matrix if, look at this condition, A into A transpose equal to A transpose into A equal to I. Any matrix satisfying this property would be called orthogonal matrix. There is one more condition. You can simply say, or if A inverse, there is one more condition. A inverse, if this is equal to A transpose, even then we call such matrix to be an orthogonal matrix. Right? What are the conditions? Any matrix satisfying this property, A into A transpose equal to A transpose into A equal to I, or simply A inverse is equal to A transpose. Here are the examples. Here are the examples. Since this is very, very important, I have taken some examples. If you look at the word called orthogonal, we use the word orthogonal in situations like this. If two vectors are perpendicular to each other, we say, right, we say the vectors are actually orthogonal to each other. When the angle between the vectors is 90 degrees, we call those two vectors to be orthogonal. When angle between two vectors is 90 degrees, we call such vectors to be orthogonal. Okay, so I'll just help like explain you in a better way. Let's take this example. -1 1 1 1. If you look at column 1, the column 1 is like this: -1 by root 2, 1 by root 2. Column 2 is like this: 1 by root 2, 1 by root 2. I just want to check what could be the dot product of these two columns. These two columns must be imagined like two vectors. The dot product you can also call as inner product. Okay, we'll call it as dot product only for some time. Dot product means something like this: C1 transpose C2. How does C1 transpose C2 look like? This is how it looks like. C1 transpose, na, so I have to transpose it. This is row, this is column. When I multiply this, I get 0. So when you get 0, it means that the dot product is 0. Whenever the dot product is 0, right? So the dot product is 0. So what we can say is C1 and C2 are orthogonal to each other. Orthogonal to each other. So the nice property of orthogonal matrix is, if you take the columns of orthogonal matrix, they are actually perpendicular to each other. That means when you take the dot product between them, the dot product would be 0. Not only this example, you take any orthogonal matrix, take the dot product of the two vectors or the dot product of two columns, the result will be 0. So this is one point about orthogonal matrix. Now there is one more point which was also asked in the GATE exam. Length of the vector. Length of the vector is also called as Euclidean norm. Euclidean norm. So how do you find it? It is represented as like this. Suppose you want to find the length of first column. Length of column 1. How do you find the length of column 1? Look at the entries. Minus 1 by root 2, 1 by root 2. So you have to square them and add them. 1 by root 2 whole square plus 1 by root 2 whole square and under the root. So this is going to give you 1. Similarly, what could be the norm of, or what could be the length of second vector? Okay, so let me include a minus sign here. Even then the answer is unchanged. Let me include a minus sign here. Yeah, minus 1 by root 2 whole square is 1 by 2 only anyway. What is length of the second column? It is 1 by root 2 whole square plus 1 by root 2 whole square under the root. So this is also 1. The nice property of orthogonal matrix is the columns of the orthogonal matrix are perpendicular to each other. The length of the columns, that is the Euclidean norm of these columns, is always 1. Right? So these are the two properties of orthogonal matrix. I'll just write. Now you can not only look at columns, you can also say this in terms of rows also. It doesn't matter. Okay, I'm just writing for columns. You can write it for rows also. The columns of an orthogonal matrix are perpendicular to each other. The columns of orthogonal matrix are perpendicular to each other. This is the first point. The second point is the length of these columns or the length of the rows will always be equal to what? 1. Length of columns, or you can also write rows, is always 1. Let's take example 2 and verify. This is one of the most important for exam point of view. So let me copy this. Just, extend this. So this is example 2. Let's look at what could be C1 transpose C2. C1 transpose means something like 1 by 3, 2 by 3, again 2 by 3. Right? I have to take transpose. No, that's why I've written like this. What is C2? It's 2 by 3, 1 by 3, minus 2 by 3. If you take this dot product, what happens is you get something like 2 by 9 plus 2 by 9 minus 4 by 9, which is what? 0. Right? Not only that, if you take C1 transpose C3, that will also be 0. If you take C2 transpose C3, that will also be 0. The columns of orthogonal matrix are perpendicular to each other. How do you know that? By looking at the dot product. Now, not only this, if you try to find the length of the column 1, the length turns out to be 1. The length of the column 2 is 1. The length of the column 3 is also 1. These are some of the nice properties of orthogonal matrix. Let me also copy this, the last one, very, very important one. This is example 3. Very important. So it's an example of what? Orthogonal matrix. If you want, you can check it. C1 transpose C2. So what would be the dot product? This into this. So it is like cos theta. There's a minus sign also. So I'll put it here. Plus sine theta cos theta. So this is 0. Now you can even find the length of the first column. What could be the length? It is simply cos square theta plus sine square theta. And then you got this under root. We know that this is 1. Similarly, try to find length of C2. It is minus sine theta whole square plus cos theta whole square. So you have this under root. Even this is also 1. These are the examples of an orthogonal matrix. Okay. So I'm going to tell you the significance of this theta after some time. So I'll just write a note point here. Okay, we will discuss significance of theta after some time. Okay, so let me continue the discussion. Let's see what could be the definition or what could be the condition for a symmetric matrix. You are all aware of this from your 10th, 11th and 12th standard. Okay, a very quick recap of this concepts. A square matrix is said to be symmetric if A transpose is same as A. There is one more equivalent condition. You can either check this or you can check this. Aij is equal to Aji. So what do you mean by Aij? When I say Aij, it means that element belonging to the ith row and jth column. So I'll just write it here for your reference. What does Aij mean? Element belonging to ith row and jth column. Element belonging to the ith row and jth column. Now, what is this telling us? A square matrix is said to be symmetric when A transpose is same as A, or element belonging to the ith row jth column should be equal to element belonging to the jth row and ith column. This is what you are supposed to check. So that's the condition for a symmetric matrix. Let's see what could be the condition for skew symmetric matrix. A square matrix is said to be skew symmetric if A transpose is same as minus A, or equivalent condition is there, that is Aij equals minus Abi. You can either check this or check this. Please remember that symmetric and skew symmetric. When I take the word symmetric and skew symmetric, I'm just looking at real matrices. Real matrices means only real numbers are allowed in it. Okay, so complex numbers are not allowed in this discussion. Okay, so this is about skew symmetric matrix. For a skew symmetric matrix, the principal diagonal elements are always 0 HCMs. Okay, now why for skew symmetric matrix principal diagonal elements are always 0? Let's try to understand. Okay, this is applicable to what? Only skew symmetric matrix. I repeat this property. For skew symmetric matrix, principal diagonal elements are always 0. Why are they always 0? Okay, so why are they 0 is, what's the condition for skew symmetric? A transpose should be minus A, or Aij must be minus Aj. Now, for principal diagonal elements, for principal diagonal elements, what happens is this I should be equal to j, na? Right? I'll just show you one example. A11, A12, A13. If you look at this matrix, this is your principal diagonal. You see that here 1, 1 you have, 2, 2 you have, 3, 3 you have, right? So for principal diagonal elements, you have what? I equal to j. So if you have I equal to j, and if you try to put it in the above equation, you have something like aii equal to minus aii, right? What is this telling you? Know, there is a number which is equal to negative of that itself. There is a number called aii which is actually equal to negative of that itself. This is possible only when, so this is possible only when aii is 0. That means all the principal diagonal elements of a skew symmetric matrix, right? All the principal diagonal elements of skew symmetric matrix are 0. So I'll quickly give you what we have discussed. Symmetric matrix condition, A transpose equal to A, or Aij equal to Aji. Skew symmetric matrix condition is A transpose equal to minus A, or simply Aij equal to minus Aji. Principal diagonal elements of skew symmetric matrix are all 0, right? So this is what we have discussed up to now. So let me continue this discussion. What do you mean by conjugate of a matrix? Okay, before I discuss this conjugate of a matrix, imagine that Z is in the form of A plus IB. Then what would be Z conjugate? It would be A minus IB. So complex number if you have and you want to find conjugate, you simply replace I with minus I. That's a conjugate concept. What is this telling us now? It's about conjugate of a matrix. So the conjugate of a matrix A is obtained by replacing elements of A with their corresponding conjugates. And a very simple observation here. If there is a matrix called A where the complex numbers are also allowed, how do you find the conjugate? So look at this activity. A conjugate means wherever you just take the conjugate of each and every element. That is very simple. So it's like 1 plus 2i minus 3i minus I, 4 minus 6i. So this is how conjugate looks like. Okay, so you can have matrices where the entries can be even complex numbers also. So if you have such matrix, then they'll ask you also about conjugate. Okay, so next I'll explain you about transposed conjugate. Transposed conjugate means first to take conjugate and then transpose the matrix. Okay, so I'll help you how to get this transposed conjugate. So for that, first you take the conjugate. What is A conjugate? 4 minus I minus I, 2 plus 3i. 5 conjugate is 5 only. Okay, it's a real number. Now you take conjugate. Sorry, we are done with conjugate. We are supposed to take transpose. So A conjugate transpose. Transpose means if this is a column, write this as a row. 4 minus I, 2 plus 3I. If this is a column, write this like a row. Minus I, 5. Okay. This is in short represented as A power theta, where theta means you're supposed to take conjugate as well as transpose. Very, very simple observations, yeah. So you need not worry about these things at all. Just a recap before we understand few more definitions. So let me show you what is Hermitian matrix. So before going to Hermitian matrix, I would like to write condition for a symmetric matrix. For symmetric matrix, we had a condition like A transpose is equal to what? A. For skew symmetric, we had a condition called A transpose equal to minus A. Okay. In this two matrices, we allowed only real numbers. But let's look at the definition for Hermitian matrix. A matrix satisfying this particular property, A conjugate whole transpose is equal to A, is referred as Hermitian matrix. Hermitian matrix condition is A conjugate transpose equal to A. Let's look at condition for skew Hermitian matrix, very similar to skew symmetric matrix. Okay, that is A conjugate transpose is minus A. Similar to skew symmetric matrix, the only difference is you have in addition conjugate operation. Okay, so these are the conditions for symmetric and skew symmetric matrices. So I just want to give you some homework activity as well. This is the homework activity for you. What are you supposed to do? You're supposed to identify which is symmetric, which is Hermitian, which is skew Hermitian from this A and B. So that is the activity that you people have to do. Let me discuss unitary matrix now. Before I discuss unitary matrix, it's better I revise what is orthogonal matrix. Orthogonal matrix. It's better I discuss what's the condition for orthogonal matrix. The condition is A into A transpose equal to A transpose into A equal to I. Just like that, if a matrix satisfies this property, that is A into A conjugate transpose equal to A conjugate transpose into A equal to I, then such a matrix A is referred as unitary matrix. This unitary matrix condition is similar to orthogonal matrix. And this is one example. These are not so important for your exam. Orthogonal matrix is important. Hermitian matrix is important. Symmetric matrix is important. Skew symmetric is also important. The remaining are not that important. Just have some knowledge about that. That is enough. Okay, so this is about some types of matrices. The important ones I tried to present. I have a question, very, very important question. This kind of questions appeared in the GATE as well. I'll read the question. I'll give you some hints and then finally give you the solution. What I'm expecting from you is you also read the question, make use of the hints, try to get the answer. Even if you don't get the exact answer, it's okay, but you try. What's the question? The number of n cross n symmetric matrices possible with the entries chosen from the set is dash. He's asking you that how many symmetric matrices can you create where the order of the symmetric matrix is n cross n, and he's saying you have to use only these numbers, right? 0, 1, 2, so on, q minus 1. Only these numbers are allowed. Only these numbers are allowed. So that's a question. How do you do this? How do you do this? So you people need to know 0, 1, 2, so on, q minus 1. He starts from 0 and it is up to q minus 1. That means there are q elements in this set. How many elements are there? Q elements in the set. Why q elements? Because he's starting from 0. 0, 1, 2, and so on, q minus 1. Because of that, there are q elements in the set. Okay. Now, let's try to look at something like this. Let me put a 2 cross 2 matrix. In this 2 cross 2, total elements are 4. Principal diagonal elements So let's put something here like this. Principal diagonal elements are 2. Okay, so remain above principal diagonal elements are 1. So if this is the principal diagonal, then this is the one but that is above the principal diagonal. Okay, so above principal diagonal elements are 1. This is just for a 2 cross 2 matrix. Okay, so let's see what happens for a 3 cross 3 matrix. 3 cross 3 matrix looks something like this. It's a 3 cross 3. Total elements are 9. Principal diagonal elements are 3. Above principal diagonal elements are, it's like I can write 9 minus 3. See here, this is the principal diagonal. How many are there? Principal diagonal 3. Total are 9. Above and below we have 6. So it's like 9 minus 3 by 2. That is 6 by 2 is 3. Right? So this is about a 3 cross 3 matrix. In the same way, what will happen for a n cross n matrix? 1, 2, let's say so on n. So this is going to be our principal diagonal. Again, the total elements are n square. Principal diagonal elements are n. Above principal diagonal are, above the principal diagonal are simply n square minus n by 2, because n square minus n are the remaining, but I just want the ones which are above the principal diagonal. So it is n square minus n by 2. Now, why I made you to do this activity is, once again, Here, the total elements for a 2 cross 2 are 4. Principal diagonal elements are 2. Above the principal diagonal are 1. I just want principal diagonal and principal diagonal plus above the principal diagonal. How many are there? It is 2 plus 1, which is 3. Similarly, I just want to write for 3 cross 3 also. What I want to write? The elements which are principal diagonal and principal diagonal elements plus the above principal diagonal elements. How many are there? How many are there? It is 3 plus 3, which is 6. Here, how many are there? Principal diagonal and above the principal diagonal. How many are there? It is n plus n square minus n by 2. If you simplify, this is like n square plus n by 2. Why am I doing all these things is very simple. You want a symmetric matrix here. You want a symmetric matrix. How do you create a symmetric matrix? For example, if I give you elements like A, B, C, D, right? Suppose you want to create a symmetric matrix. I'll just give an example here. Example, it's like A, B here. If B is here, then you have to put again the B here to make it symmetric. If you put B here, then there is no choice for you, right? There is no choice here except B. If you put B here, then by default, this is also B. Now you can put C here. So this is one such example of a symmetric matrix. You can put any element here. You can put any element here. You can put any element here, but once you put any element here, the same has to appear here, right? So this is for a 2 cross 2 mix, yeah? You can put any choice here. You can put any choice here. You can put any choice here as well, but you don't have that choice for this particular element. The reason is, if you want to make it symmetric, whichever element you put here, the same element should appear here. Okay, that's how you create a symmetric matrix. I hope this discussion is clear. Right now, you can put total elements are q na. You can put any of the q elements. So this can be filled in q ways. This can be filled in q ways. This can also be filled in q ways. Right now, there is no choice here. Whichever element you put, you have to take that and put it here. Okay, so there is no control on this. Whatever element that you are going to put here, the same element will appear here. So how many symmetric matrices possible is, since this can be filled in q ways, this is in q ways, this is also in q ways, q cube. Okay, so if one experiment results in q outcomes, another experiment also is resulting in q outcomes, the third experiment also resulting in q outcomes, then you say q into q into q, total possible outcomes are there of this experiment. So q cube symmetric matrices are possible. Okay, this is for a 2 cross 2. What will happen for a 3 cross 3? For a 3 cross 3, this can be filled in q ways. This can also be filled in q ways. This can also be filled in q ways. This can also be filled in q. Once you put any element here, the same element comes and sits here. Once you fill any element here, the same element comes and sits here. You fill any element here, the same element comes here. So there is no control on these elements actually. You can change principal diagonal elements and the ones which are above. Okay, so how many symmetric matrices possible here? Q power 6 symmetric matrices are possible. Let's discuss it for a n cross n case. Now here you can put q. Here also you can put q. Now if you put any element here, the same appears here. The same will appear here. The same will appear here. right? So there is no control on this. You cannot change these elements. Whatever you put here, you have to take them and put it here. So for that purpose, the answer is q power n square plus n by 2 symmetric matrices are possible. Okay, so let's see whether we have that option or not. N square plus n by 2 can be written as n into n plus 1 by 2. So it is A. It is A. I'll give you 1-2 minutes time. You can go through it. I can explain you also this question once again. Okay, I'll explain you this question once again. So please just go through this question. The idea is very simple, guys. The idea is very, very simple. You just have to see for a n cross n matrix, how many are principal diagonal elements, how many elements are above the principal diagonal elements. You can actually change them and you can generate symmetric matrix. Okay. Okay, let's go ahead with the discussion. Again and again, the idea is very simple. Yeah, if you people can understand this, for a n cross n matrix, the total elements are n square. Principal diagonal elements are n. So the remaining elements are n square minus n. But I want the ones which are above the principal diagonal. So I'll divide n square minus n by 2. Now I want the ones which are principal diagonal, also the ones which are above the principal diagonal. So what will you do to get that? We just have to add n and n square minus n by 2. Adding that will give you n square plus n by 2. What is this n square plus n by 2 telling you? There are n square plus n by 2 number of elements which are in the positions of principal diagonal as well as which are above the principal diagonal. You can change each of them, okay, in q ways. So the total symmetric matrices possible are q raised to n square plus n by 2. So that is about this question. Okay, so now comes the most important topic, that is determinants. What I'm going to explain is how do you find determinants in the most efficient way. Okay, in this discussion we'll see how to find determinants in the most efficient way. Before that, before I discuss some efficient ways, what I will do is I'll just go through some the standard procedure of finding the determinant. So let's look at this. It's like a 2 cross 2 matrix. I'm interested in finding the determinant of this. It is very simple. That is AD minus BC. You all by now you know. I mean, you all know this now. For a 2 cross 2, it is simply AD minus BC. For a 3 cross 3, how do you find it? Okay, so try to follow me. I'm looking at the first element in the first row, that is 1 into -1 whole power 1 plus 1. How did I get this 1 and this 1? This element belongs to the first row and first column. This belongs to the first row, first column. Because of that, I have got 1 and 1 into a minor. So what does this minor mean? For that, you just have to hide this and this. So when you hide this and this, what you see is something is left over. 2, 3, 4, 7 is left over. So take those elements, put it here, 2, 3, 4, 7. And after this, I'll again say plus. What is the next element here? 1. I'll take 1. This belongs to which row? First row. This belongs to which column? Second column. So I'll just write -1 whole power 1 plus 2 into a minor. So what could be the elements in this minor? For that, I have to just remove or hide the first row and the second column. If I hide them, then what is left over is 1, 3, 1, 7. I'll take those elements. 1, 3, 1, 7. Next, I'll go with the last element of the first row, that is 1. 1 into -1 whole power. This particular element belongs to the first row and the third column. So first row and third column. So 1 plus 3 into a minor. So what could be the entries in that minor? So for that, I just have to hide this and this. So what is left over? 1, 2, 1, 4 is left over. So take those elements. 1, 2, 1, 4. Before I simplify it further, what I would like to do is I would like to highlight that. Look at this. The ones which are in the black. What are these called? These are called as minors. I'll also try to highlight few more things like this. -1 whole power 1 plus 2 into this minor. The ones that is highlighted in red are called cofactors. What are these called? Cofactors. Through this example, I just want to give you a recap of what does a minor mean, what does a cofactor mean. Okay, so now let's simplify it further. Simplified further means, okay, this is -1 whole power 1 plus 1. This is like plus. -1 whole power 1 plus 3. 1 plus 2 is 3. -1 whole power 3 is -1. -1 whole power 4 is +1. Alternatively, you're getting 1 and -1. So let's take that also into the account. So this is like 1 into 14 minus 12. There's a minus because of this -1 whole power 3. I'll include that. 7 minus 3 plus 1 into 4 minus 2. So this gets simplified to 2 minus 4 plus 2, which is 0. The determinant of this matrix is 0. So this kind of matrix is termed as singular matrix. Why this is termed as singular? Because det is 0. So if this is det A, here det A is 0, na? That's the reason why this is termed as what? Singular matrix. I just want to explain, or I just want to give you one definition. Let's see what could be the definition. I'm sorry. Just a minute, something happened here. Yeah, I just want to give you a definition. So how do you define a determinant? How do you define a determinant? So let me show you here. This one happens to be the elements of the first row. The ones which are in the red color are their cofactors. So take the elements of the first row, multiply them with their cofactors, add them. I repeat it again. Take the elements of the first row, find their cofactors, okay, multiply the elements of the first row with their cofactors and add them. If you put this in a sentence form, then it is something like this. It is sum of product of elements of a row. You can actually also include a column. You need not work with row. You can also work with column also. It is sum of product of elements of a row or a column with their cofactors. So I tried to explain you what does a cofactor mean like, or how does a cofactor look like, or how does a minor look like. So this is about the determinant definition. This is applicable only to square matrices. Applicable to what? Only square matrices. Okay, so this is about this example. I'll make you to do this activity here. If you can give me 5-10 minutes time, I'll do this activity. For the matrix given below, before I read this question, before I solve this, I just want to tell that in the exam, they ask you to find the determinant. You are not going to follow this procedure. Okay, this is just some kind of activity which will improve your understanding skills. Okay, so let me read this question. For the matrix given below, verify the determinant using all the rows and the columns. Okay, so what I'll do is I'll try to find the cofactor matrix. Cofactor matrix of A. So how does that look like? The cofactor matrix of A is like a 3x3 matrix. So total there are 9 elements. So we need to find those elements. For example, cofactor of A11. A11 means this element here. This element. So how do you find cofactor of that? It is -1 whole power 1 plus 1 into a minor. Okay, so to find the elements in this minor, you have to hide this. So if you hide, what are the elements left over? 1 minus 2 minus 2 1. So let's write these elements here. 1 minus 2 minus 2 1. So how much is this? This is 1 minus 4, which is -3. So the final answer here is -3. So I'll take this, I'll put it here. Likewise, cofactor of A12. A12 means I'm talking about this element, right? So for that, what you need to do is you need to write like this: -1 whole power 1 plus 2 into a minor. So what could be the entries in that minor? You need to hide this as well as this column. So the elements left over are 2, -2, 2, 1. 2, -2, 2, 1. Now try to simplify this. This is negative here, by the way. 2 plus 4 is 6. There's a negative outside, so it's -6. You put it here. I'll do one more calculation for you. Cofactor of A13, -1 whole power 1 plus 3 into a minor. So what could be the entries in this minor? For that, you need to hide this, hide this. So what are left over? 2, 1, 2 minus 2. 2, 1, 2 minus 2. This is giving you a +1 here, +1 here. So this is -4 minus 2, which is -6. So take this -6, put it here. I'll give you few minutes time. I'll give you 1 or 2 minutes time. What you people have to do is fill this elements as well. You people have to answer me this elements. So whoever is ready can raise the hand. I'll ask them. Take your time. Try to find the remaining cofactors and let me know. Whoever is ready can raise the hand. I'll take entries from them. Yamuna, you need to find all the cofactors, not just one cofactor, remaining all 6 cofactors. Yeah, please do that activity. So if you are ready, tell me those elements. Take 1 minute time. Sindham Snikta, okay. Hello.
Sir.
Yeah, are you ready with the entries?
Yes, sir.
Okay, just a moment. You give me the entries, the other students will verify, okay? Yeah, give me the entries.
A11 minus, okay, A21, 6,
Okay,
A22, 3, A23 minus 6, A31, 6, A32 minus 4.
minus 4 is wrong actually. You can
Second.
verify it. I'll wait for you.
It is minus 6, sir.
Okay, minus 6. The last cofactor, please.
4.
No, please verify that also.
Yes, sir, it's again 6.
It's 6. You do it in a relaxed way. Don't worry.
Okay, sir.
Don't be in hurry.
It's 6, sir.
Are you sure? I don't think so. It's 6. Check it. Cofactor of this, na? So
Yes, sir.
cofactor
Yes, sir. Just a second.
of A33 is minus 1 whole power
1
plus 3 into a minor. So
is
minus 1 minus 2
plus 3.
2 1. So this is minus 1 plus 4. Minus 1 plus 4 is 3. Yeah. So I think 3 is the right one. Okay.
Yes, sir.
I'll ask other students whether they also got the same result or not. Okay. So let's verify
Yes, sir.
with other students. Vamshi Krishna Reddy, did you get the same thing?
Hello? Yes, sir.
Is it matching?
Yes, sir, it's matching.
Okay, it's matching. I'll just verify with one more student and then we'll continue this. Pavitra?
Sir.
Is it matching?
Yes, sir.
Okay. Fine, fine. So I have muted everyone. So I have verified from a few students. They said whatever cofactor we have written is okay. Now, why did I write this? What's the question? The question is about verify the determinants using all the rows and all the columns. Okay, so let's verify that. So what do you mean by verification is, I just want to find det using first row. Det using the first row. you there? Hello, are you there? Okay, I think it looks like he's not available. Anto, are you there? Aditya Deshpande, are you there?
Yes, sir.
Can you give me the elements of the first row of A?
-1, -2, -2.
Okay, -1, -2,
-2.
Can you give me their respective cofactors?
-3, -6, -6.
Have you taken elements of the first row of A multiplied with their cofactors?
Yes, sir.
Can you simplify this for me? How much is this result? 3 plus 12 plus 12, I think it is 27.
27. Yes.
Now also help me with this that using second row. Give me the elements of second row of A.
1, -2.
Second row of A.
2, 1, -2.
What are their cofactors?
6, 3, -6.
Now I have taken elements of second row of A multiplied
Yes.
with cofactors from the second row. Let's add
Yes,
them.
sir.
Let's see how much would be the sum. This is 12, 3,
27,
15, 27 again.
Yes, sir.
One more nice observation. Okay. That using, let's say, third row. Give me the elements of the third row.
2, -2, 1.
Their cofactors.
6, -6, 3.
Let's see how much is the sum now.
27.
So 12 plus 12 plus 3 again, 27.
Yes, sir.
Okay, this is using the rows. Can we
Yes,
do
sir.
the same thing using columns?
Okay, sir.
Yes. So I'll say first column. Give me the first column elements of A.
-1, 2, 2.
Their cofactors.
-3, 6, 6.
So I have taken
27,
elements
sir.
of first row, first column of A multiplied with their cofactors and then adding it. So how
Yes.
much will I get?
27, sir.
Okay. I'll say that using second column. Give me the elements of the second column of A.
-2, 1, -2.
Their cofactors.
-6, 3, -6.
How much is the sum now? Is it
27,
27?
sir. Yes,
One
sir.
more last verification. Okay, one more last verification. That is using the third column.
Yes, sir.
That using third column. Okay, we will not do this in the exam. Just some activity. Make ourselves confident that we can use any row or any column for finding the determinant. Third column of A.
-2, -2, 1.
It's 2 minus 2, 1.
-2, -2, 1.
No, yeah. Look at this.
Third
Oh, I'm
column,
sorry.
sir.
I'm sorry. I'm sorry. I'm sorry. You are right. You are right. So
Yes.
I'm very sorry. -2, -2, 1.
-2,
Their
1.
cofactors.
Yes, sir.
Minus
-6, -6, 3.
-6
3.
and 3. Is it 27?
Yes, sir.
All the students who are listening to this class should be confident that you can find the determinant using any row or any column of the given matrix. Can you tell me, Aditya, what is the definition of a determinant now?
Determine it is the sum of elements of rows or column with their cofactor.
You should have said sum of product of elements of a row or a column with their
Yes, sir.
cofactors.
Yes, sir.
Okay,
Sum
can you
of product.
repeat that?
It is the sum of product of elements of the row or column with their cofactor.
Okay, fine. One more activity, I'll just do it. For that, I just need your help.
Yes, sir.
I have A and cofactor of A in front of us,
Yes,
what
sir.
I would like to do is I would like to take sum of product of elements of first row with cofactors from another row. Okay, are you ready?
Yes, sir.
For example, -1,
Minus 1, minus 2, minus 2,
minus 2. Give me the
minus-
cofactors from the second row.
second row, 6, 3, minus 6.
If you add them, you will see that the result is 0 actually.
0.
If you want to
Yes,
check
sir.
it, is it 0?
Yes, sir.
Now again, I take the first row again.
Sir,
Take the cofactors from the cofactors of the third row. Yeah, is it
excuse
0 or
me,
not
sir.
0?
Sir, it's not 0. First row, in the previous statement, sir, minus 6. Okay, yes, sir. Correct, sir.
Again, I'm taking the first row of A and the
Yes, sir.
cofactors of the second row. So second row is over, third row. So it's 6 here.
6 minus 6, 6 minus 6, 3.
Yeah. So how much is this? Is it also 0?
Yes, sir. 0, sir.
Okay. So I just want to tell the whole class one nice point. So if we take sum of product of elements of a row with cofactors from the other row, then the result is always what? It is always 0. The result is always 0. So if we take sum of product of elements of a row with cofactors from the other row, then the result is always 0. Okay. So these are some of the nice points about the determinant. The result is always 0. So far, whatever we have done is like we have calculated by expanding the determinant. Okay. So we can use any row or any column. In the exam, if they ask you a question on the determinants, use that particular row or that particular column which has got more zeros in it. Why are we looking at that column or that row which has got more zeros in it? Because according to the definition of determinant, it is sum of product of elements of a row with their cofactors. So if you have already more zeros in a row, then you need not find the cofactors. So while finding the determinants, search for that row or that column which has got more zeros. So I'll just write that note point. While finding determinants, search for that row or a column which contains more zeros. Now one may ask, sir, what if there are no zeros at all? That means all the elements are non-zero. Then searching for a row or a column which contains more zeros is meaningless. In such case, what you can do is you can actually create zeros without changing the determinants. So how is that done? Will be discussed now. Okay, so just a recap of what we have done. What is determinant of a square matrix? I clearly said this determinant concept is applicable only to square matrices. So it is simply the sum of product of elements of a row or a column with their cofactors. So what is a cofactor? What is a minor? is also summarized here, right? So I want you people to go through this. This would be uploaded in your student portal. You can make a note of this. I hope you people have got idea about determinants. We haven't seen the efficient ways of solving the determinant. What we have seen is just what is the definition of a determinant here. Okay. See here, before I discuss some nice ways of handling this determinants, if you look at this example, this is a 3 cross 3 determinant. To find the value of this 3 cross 3 determinant, I needed 2 cross 2 determinants. It might be confusing to you people, but I'll repeat this again and again. I was interested in finding the determinant of a 3 cross 3. For that, I needed 2 cross 2 determinants. In the same way, if you have to expand 4 cross 4, I need 3 cross 3 determinants. So this is where you people will be worried, right? Just to expand 4 cross 4, we need 3 cross 3. And each 3 cross 3 needs 2 cross 2, right? Some of the students might be feeling like, what is he discussing? Okay, see, I'm just telling you that if you go by the usual way, it is going to be very difficult. I'll just do an activity here. Suppose you have a 5 cross 5 determinant. To get the answer for that, we need in the first step 5 4 cross 4 determinants. 5 4 cross 4 determinants. Each 4 cross 4 needs 4 3 cross 3 determinants. Each 3 cross 3 needs 2 cross 2, right? That means it is going to be too lengthy if you go by this expansion approach. So then what is the alternate way? Let's now focus on what could be the alternate way. So let's go ahead. So this is what is the efficient way. So I'll just write elegant way to find determinants. Elegant way to find determinants using type 3 operation. So what is this type 3 operation? We will have a discussion on it now. Effects of row operation. So what is he saying? Let B be a matrix obtained from A n cross n by one of the 3 elementary operations. What could be the impact on the determinant? So you might feel it somewhat new. So what I'm saying here is, imagine you have a 3 cross 3 matrix here, something like this. Using this 3 cross 3 matrix A, I'm going to create a new matrix called B. So how I'm going to create is, for example, if it is type 1, what is this type 1 saying? Interchange the rows I and j. So for example, interchange R1 and R2. If you interchange R1 and R2, you get a new matrix called B. How does that look like? It looks like this. Maybe I should have used some ABCD. Okay, so I'm sorry for that. What I'll do is I'll remove all this. I'll just put some ABCD values like this. So let's say I have a matrix called A, which is like this: A, B, C, D, E, F. Let's say G, H, I. Right? So what do you mean by interchange R1 and R2? It means something like this. Now this is D, E, F, A, B, C, G, H, I. Right? How is B obtained? B is obtained by interchanging the rows R1 and R2. Right? So whenever I say type 1, that means some interchange of rows has happened. So that you have to keep in mind. Let's see, what do you mean by type 2? Type 2, let's see. Type 2 means multiply row I by alpha, which is not equal to 0. Okay. So example, multiply row 1 by alpha, where alpha is not equal to 0. If you do that, you get a new matrix, something like alpha A, alpha B, alpha C. And then the remaining elements are same. So I got a new matrix called B now using type 2 operation. I'll just write a note point here. When you use type 2, only a particular row is multiplied by alpha. Okay, not all the elements of A, only a particular row. Only a particular row. Particular row is multiplied. Only a particular row is multiplied by alpha. Okay. At the same time, suppose you are interested to find if you have a matrix called C, which is like alpha A. Okay, only a particular row is multiplied by alpha using, say, type 2. This is the note point. Now, I just also want to make sure you people have some clarity here. Now, what does C equal to alpha A mean? When you say alpha A, that means each and every element of A is multiplied by alpha. So you get alpha A. So there's a difference between type 2 operation and multiplying a matrix by alpha. A very, very clear difference is there. When I perform type 2 operation, only a particular row has been multiplied by alpha. But if you multiply alpha to a matrix, not just a row, all the rows now got multiplied by alpha. So type 3 operation is different from alpha A. Keep that in mind. Now, let me also explain you type 3 operation. Type 3 operation. So let me read what is type 3 here. It says add alpha times row I to row j. Alpha times row I to row j. I'll just put one example in front of you. Something like R3 is replaced with R3 plus, let's say, alpha times R1. So you get a new matrix called B now. How does B look? It is like A, B, C, and then D, E, F. Now when it comes to row 3, now row 3 is replaced with row 3 plus alpha 1, alpha times R1. That is something like G plus alpha A, H plus alpha B, I plus alpha C. I'm just explaining you this operations in detail so that you'll not get confused. I hope you people understood what are type 1, type 2, type 3. Yesterday also, I tried to explain you these operations. Okay. Now, what we have done so far, we learned about 3 operations. Type 1 means interchanging the rows. Type 2 means replacing a particular row with multiple of itself, where that multiple is not equal to 0. Type 3 means you are replacing a particular row with combination of itself plus multiple of another row. By doing this, you actually created new matrices. In the first case, it was like this. The rows were interchanged. Second case, you see that the first row is now multiplied with alpha. In the last, that is type 3, you see that the third row is different now. What will happen to the determinant of B now? Is there any relation between the determinant of B and the determinant of A? Let's try to find it out. The determinant of B is simply minus times the determinant of A if it is type 1 operation. That means if you go for row interchange, you have to introduce a minus sign. That's the first point. Second point, for type 2 operation, it is simply alpha times the determinant of A. Please note that here for type 2 operation, only a particular row has been replaced with alpha. Only a particular row has been multiplied, not replaced, multiplied by alpha, not all the rows. So the determinant is multiplied by alpha. The most important observation is the type 3. The determinant of B is same as that of determinant of A. So because of this, right, this is going to help us like anything. This is going to help us like anything. So whenever a question is asked on determinants, try to make use of the type 3 operation. So again and again, I'll say, look at type 3. R3 is replaced with R3 plus, let's say, alpha times R1. This is called type 3R. The common mistakes made by the student is they do this, that is R3 is replaced with, let's say, beta R3 plus alpha R1. This is not type 3. Not type 3. If you do this operation, determinants will not change. The determinant value will not change. Determinant does not change. If you look at this, the determinant is going to change. Determinant will change. Okay, so that is about the type 3 operation. If you can give me some time, I'll explain you in more detailed way. Okay, more detailed way. So before I discuss that in more detailed way, I just want to write again here the determinant of B, because it's type 2 operation. The determinant of B is alpha times the determinant of A. If you look at C, the determinant of C, first of all, how did you generate C? It is simply alpha A. When you say alpha A, alpha is multiplied to all the rows. So because of that, what you get is alpha power n into the determinant of A. So what n stands for here? Where n is order of A. Okay, where n is order of A. In the same way, what will happen to determinant here? The determinant of B is minus the determinant of A. Okay, so the most important operation here is the type 3 operation. So I'll write here the determinant of B is same as that of determinant of A. I would like to spend some time on this type 3 operation, give you some idea. Okay, so for that, what I'll do is I'll write A here. I'll write A again, which is like A, let's say B, C, D, E, F. Let's take another element called X, Y, Z. Let's say this is A. You created B, something like this here. You used type 3 where R3 is replaced with R3 plus, let's say, alpha R1. So because of this, you got B. How does that look? A, B, C, D, E, F. This is like x plus alpha a, y plus alpha b, z plus alpha c. I just want to show you that the determinant of A is same as that of determinant of B, right? Both the determinant values are same. I just want to show you that, right? If you can spend a few minutes on this, you'll get that idea. So I just want to find the determinant of A first. I want to expand that using row 3. Let's expand this using row 3. So it's x into minus 1 whole power 3 plus 1 into the minor. That is B, C, E, F plus y into minus 1 whole power 3 plus 2 into a minor. So what is that minor? That minor is A, C, D, F plus Z into minus 1 whole power 3 plus 3 into a minor. That minor elements are A, B, D, E. Right now, I just want to give you a note. Wherever you see this, you people have to tell that this is the determinant of A. Okay, this is the determinant of A. Now, people look at this. How I'm going to find the determinant of B? The determinant of B also I'll use using the third row. Something like x plus alpha A into minus 1 whole power 3 plus 1 into, you get the same elements here. Whatever you write here, you can put it here. B, C, E, F plus, go to the next element, y plus alpha B into minus 1 whole power 3 plus 2. Whatever elements you see here, the same elements will appear here also. AC, DF plus Z plus alpha C into minus 1 whole power 3 plus 3 into a minor. What are the elements of that minor? Again, you just have to hide this and this. So A, B, D, E. We are almost done. I'll just group X, Y, Z together, A, B, C together. So if you group X, Y, Z together, so it looks like this: X into minus 1 whole power 3 plus 1 into B, C, E, F. So look at whatever I'm writing. I'm just grouping the terms. Now, few more terms are left over. Before I comment on few more terms, try to see that this is same as this. This and this are exactly same. That means this highlighted portion is nothing but det A. Now, what are the terms that are left over? Something like alpha A into this plus alpha B into this plus alpha C into this. That is where alpha is actually common. Let me put alpha out. If I put alpha out, what is left over? A into minus 1 whole power 3 plus 1 into BC EF plus B into minus 1 whole power 3 plus 2 into AC DF plus C into minus 1 whole power 3 plus 3 into A, B, D, E. Okay, look at the killer observation. Now this A, B, C happens to be the elements of the first row of A. I repeat it again and again and again. A, B, C happens to be the elements of first row of A. If you look at these guys, these guys are nothing but the cofactors from the third row. What are these? These are the cofactors from the third row. What are these ones? A, B, C? The elements of the first row of A. The highlighted ones in the red are cofactors from the third row. What are you doing is you are taking the elements of the first row of A, multiplying with cofactors from the third row, that will always be 0. That will always be 0. So I'll try to highlight something like this. This is always 0. That means what's the conclusion? The conclusion here is det B is same as det A. Right? Det B same as det A. Type 3 operations will not change the determinants. Most of the students, after teaching at this level, they do this kind of operations. They'll come to the teacher saying the determinant answer is not matching, right? So one student has posted, even God can't help you. So if you misunderstand, God also cannot help you. Try to understand the concepts in a better way so that you can help yourself. God need not come, right? God is within you only. So if you try to understand the concepts, you can help yourself. This operations will change the determinant. This operations will not change the determinant. Type 3 will not change the determinant. Very, very important note I'm going to give now. Very important note, which is useful for the GATE exam. That note is as follows. If you replace R3 with R3 plus, let's say, alpha R1, that won't change. If you replace R3 with R3 plus alpha R1 plus, let's say, beta R2, even then that won't change. Suppose if you replace R3 with R3 plus R1 plus R2, even then that won't change. Suppose you have a n cross n square matrix. N cross n. Suppose you do an operation like this. Rn is R1 plus R2 plus so on plus Rn. If you do an operation like this, even then the determinant won't change. You people should be very, very confident of using these operations. Right? Now, how do you say that the determinant won't change? You just apply the same logic that we have discussed here. Right? If you apply the same logic, you will understand this. If you can do this kind of operations, if you can create more zeros into that, you can simplify any determinant. What usually happens, everywhere in the YouTube or in all the coaching centers, they'll give you a trick for a 3x3 determinant. They'll ask you to repeat certain columns, or I don't know, because I don't know that trick. They ask you to repeat some pattern, they put some lines and they create something, and they'll find the determinant. It will also take some time. That will work for 3x3. Suppose if the question is about n cross n, that trick will not work. If it is a 5x5 determinant or a 6x6 determinant, that trick will not work. So better you stick with the elegant ways. That means whatever may be the order, if you can find some elegant ways, that is going to help you. So let me quickly give you a recap of what we have discussed. The discussion was about determinants. We looked at how to find a 2x2 determinant. We looked at 3x3. We defined what is a determinant. We said you can find determinant using any row, any column. We verified it through one example. And we are looking at some good ways of finding the determinant. So those are using type 1, type 2, type 3. Type 1, if you use, will the determinant change? Yes, it changes by a minus sign. If you use type 2, will the determinant change? Yes. Now it would be det B would be alpha times det A. If you use type 3, the determinant is unchanged. Instead of type 2, if you simply say that there is a matrix called alpha A, when you say alpha A, all the rows of A are multiplied with alpha. If you use type 2, only a particular row is multiplied by alpha. Okay, understand the difference. Alpha A means all the rows are multiplied by alpha. In such case, the determinant would be alpha power n into the determinant of A. So I also gave some note points. The common mistake made by the students is they use this kind of operations and they don't care about the determinants and they get a wrong answer. So don't do this. I'm repeating. If you do this, the determinant is unchanged. If you do this, determinant will change. Okay. Yeah. So let's now quickly look at the properties of determinants. I hope this discussion is going well. So let me quickly discuss the properties of determinants. Whatever I said earlier, right, all these along with these properties, if you can combine in the exam, you will hardly take 1 or 2 minutes to solve any question. Okay, so what you need is a thorough understanding of these properties and a good practice. Okay, so let me read these properties now. What does the first property say? Transposition does not alter determinants. So what does this mean? If you do transpose operation, the determinants will not change. So I'll just give you one simple example. If you have a matrix like this, the determinant of this is AD minus BC. Okay, the determinant of this is AD minus BC. The determinant is AD minus BC. How does A transpose look like? A transpose is A, C, B, D. What would be the determinant of A transpose? It is AD minus CB. AD minus CB same as AD minus BC. I took just a 2 cross 2. Not only for 2 cross 2, for n cross n also this is true. This is about the first property. Let's look at the second property. Second property, all these properties were asked in the GATE exam. Okay, all these properties. The second property says det AB is simply det A into det B. Okay, I'm not proving this. This is a very difficult proof. I'm going to avoid this. I'm just highlighting this result. If you use this, what would be determinant of A square? The determinant of A square would be determinant of A into A, which is det A into det A, because I'm using the above property. So because of that, it would be det A whole square. What would be det of A cube? In the same way, it would be det A power 3. Like that, what would be det of A power n? It would be det A whole power n. Okay, so using the second property, I have derived few results. Determinant of AB is det A into det B. At this point of time, what I would like to say is, see here, det AB is always equal to what? Det A into det B. Some students, they go a step forward, they feel det A plus B is equal to det A plus det B. No, this is not true in all the cases. This is not true in all the cases. So keep this in mind. Det of A plus B may or may not be equal to det A plus det B. In some cases, it may be equal. In some cases, it may not be equal. So because of that, I'm writing det of A plus B is not equal to det A plus det B in general. So don't use this property. So this is about the second property. Let's see the third property. If you are looking at a non-singular matrix, A is non-singular if and only if det is not equal to 0. A would be called singular if and only if det A is 0. A is non-singular if and only if det is not equal to 0. And it is singular if and only if det is equal to 0. You all know this from your 10th, 11th, and 12th standard about the singular and non-singular matrices. Next one is triangular matrix. Look at this. Below this, you have all zeros. Look at T22. Below this, you have all zeros, right? So what is this? This is an example. Example of an upper triangular matrix, right? If you are dealing with upper triangular matrix, lower triangular matrix, or a diagonal matrix, okay, the determinant of that is simply the product of principal diagonal elements. Okay, if you are given directly a triangular matrix can be upper triangular or lower triangular, or it can be a diagonal matrix also. Only for such matrices, the determinant is product of principal diagonal elements. That's what is highlighted in the next property. Likewise, we are supposed to discuss few more properties. Let me discuss few more properties. So you look at this. The determinant of a triangular matrix or a diagonal matrix is product of what? Principal diagonal elements. What students usually do is they don't care what the property says. They create their own properties. Some matrix would be given which is not triangular, right? Even though it's not triangular, they take the product of principal diagonal elements and they claim that that's a determinant. Don't do that. Whatever I said, that is product of principal diagonal elements, would be your determinant only when you are dealing with triangular matrices. So what do you mean by triangular matrix? Upper triangular or lower triangular or even a diagonal matrix. Okay, this is applicable only to this. Let me read out the next property. If each element of a row or a column in a matrix is 0, then the value of its determinant is 0. Okay, what is he saying is A, B, C, D, E, F, 0, 0, 0. The determinant is 0 into its cofactor plus 0 into its cofactor plus 0 into its cofactor. It's like I have used or have expanded this determinant using third row. So obviously answer would be 0 only, na? Right? If any row or a column is 0, then the determinant of that matrix would be 0. Very, very important one. A row or a column, if it is entirely 0, then the determinant of that would be 0 without any calculations. I also gave the explanation, the reason for that. What is the next property saying? Look at this property. Read it. If two rows or two columns of a matrix are identical, then the determinant is 0, it seems. So saying something like this is creating an example. Let's create one example. A, B, C, D, E, F, D, E, F. You can see that row 2 and row 3 are identical. Row 2 and row 3 are identical. What I'll do is I'll perform an operation like this. R3 is replaced with R3 minus R2. This operation is like type 3 operation, which will not change the determinant. So the determinant value is whatever the earlier determinant. Now also you will get the same one, that is ABC. Third row is entirely 0. Since the third row is entirely 0, the determinant of this would be 0. So what is this point saying? If you have got identical rows or identical columns, then the determinant of that matrix would be 0. Let me explain the two properties in the next page. Okay, so what are these saying? The determinant of a skew symmetric matrix of odd order is always 0. The determinant of a skew symmetric matrix of odd order is always 0. So let me take this property to the next page. The determinant of a skew symmetric matrix of odd order is always 0. What are the keywords here? Keywords are odd order. Also, it is applicable only to skew symmetric matrix. Okay, if A is skew symmetric, then what we have? We have A transpose equal to minus A. I'll put determinant on both sides. So minus A can be written as minus 1 minus 1 like this. We understood one property that A transpose and A have the same determinant. Transpose operation will not change the determinant. So what I can write here is this is det A only. This is acting like alpha. So I'll just write it like this. If you have something like this, what is det C? It is actually alpha power n into det A. So this is minus 1 whole power n into det A. You can actually bring this together. Det A is common. So what is left over is 1 minus 1 whole power n. Okay, so this must be 0. Now we are actually looking at a case where n is odd. Now when n is odd, what happens is minus 1 whole power 3 is minus 1, minus 1 whole power 5 is minus 1, minus 1 whole power 7 is minus 1. So when n is odd, what happens is you get something like twice det A is 0, which implies det A must be 0, right? Because when n is odd, 1 minus 1 whole power n is actually equal to 2. If you have doubt, check it. Put some odd numbers there. 3 you put. If you put 3, you get 1 plus 1, which is 2. If you put 5, again you get 1 plus 1. Put 7, 1 plus 1, right? So for a skew symmetric matrix of odd order, the determinant is always what? 0. You might ask, sir, what will happen for a skew symmetric matrix of even order? It can be anything. It can be anything. Whatever property I said, it is applicable only to skew symmetric matrices. Only to skew symmetric matrices. The last property, let me explain. So it is about an orthogonal matrix. It says the determinant of an orthogonal matrix is either 1 or minus 1. Let's check it how. What's the condition for orthogonal matrix? A into A transpose must be I, na? Right? I. Let's put determinant on both sides. Everyone knows how does I look like. The principal diagonal elements are all ones. The remaining elements are all zeros. The determinant of identity matrix is 1. The determinant of AB is determinant of A into determinant of B, which is equal to what? 1. But we know that A transpose determinant and A determinant are same. So what you get is determinant of A square is 1, which implies the determinant of A is plus or minus 1. So what does this mean? Either you will have the det to be 1 or -1. Simultaneously, you cannot have 1 and -1, right? Either you will have 1 or -1. At the same time, 1 -1 not possible. It can be 1 or -1. Look at the statement that I gave. And I gave you the valid explanation for that. The determinant of an orthogonal matrix is either 1 or -1. Okay, let me quickly recap the properties of the determinant and then go for a break. If you look at your previous gate questions, okay, or the ones which you are going to get in 2022, for sure you get questions from these discussed properties only. I'm very confident about that. Because of that, I'm just giving you a recap. Transpose operation will not change the determinant. The determinant of AB is det A into det B. With this, what you can do is, you can say the determinant of A square is det A power 2. Because of this, what happens is, if you have to find the determinant of A power n, you need not find the matrix A power n. Right? To find the determinant of A power n, you need not find A power n. Find the determinant of A and then raise it to the power n. That would be the determinant of A power n. Condition for non-singular matrices, the det must not be equal to 0. Condition for singular matrices, det must be equal to 0. Triangular matrices means upper triangular, lower triangular, or diagonal matrices. For this class of matrices, the determinant is simply product of principal diagonal elements. Okay. If you have a row or a column which contains all zeros, the determinant of that matrix would be 0. If identical rows are there or identical columns are there, the determinant of that matrix is also 0. Skew symmetric matrix of odd order, the determinant would be 0. Orthogonal matrix determinant is 1 or -1. Okay, so I'm going to go for a break here. The break is up to 7:15. Okay, 7:15 to 7:30, I'll take doubts. 7:15 to 7:30, I'll take doubts. From 7:30 onwards, I'll continue this discussion. Okay. -15 I'll put for the doubts. So whatever doubts I can clear in that time, I'll clear. If doubts are remaining, I'll take after the class. Okay. My dear students, doubts? If you have any doubts, you can ask. Shankar Jaiswal?
Hello, sir.
Yes.
Fine, thank you, sir. Sir, my doubt was from last lecture, sir. Sir, in example number 2,
Okay.
yesterday one guy asked the same doubt, sir, but like I wasn't very clear on that. Sir, let's just say in exam, in GATE, if they ask that how many non-basic columns are there, what shall we write? 2 or 3, sir?
They'll ask you how many non-basic columns of A or how many non-basic columns of AB. They'll clearly specify.
Okay, sir. Thank you, sir. That was
Yeah. Vignata Jasti?
Yes, sir.
Your doubt?
Sir, can we have a discussion on finding determinant of higher order, like 4 cross 4 or 5 cross 5?
Yes, we will have it now. Don't worry.
Yes,
We are yet to discuss that, na?
yes, sir. Okay.
Not 4 cross 4, 5 cross 5, even 6 cross 6 also appeared in the GATE exam. Okay, we will see how do we deal with that.
Yes, sir. Sure, sir. Thank you, sir.
Yukta?
Sir, my doubt is from last class, sir.
Okay.
13th question, sir.
Yes.
Sir, while verifying this second case, sir, minus 2 case, we are not doing in row echelon form. So we are not converting it into row echelon form.
See here, the question is about the system should have unique solution, correct? Hello?
Yes, sir.
The system should have unique solution, correct or not?
Yes.
Now, with k equal to minus 2, what are these elements? Are these elements 0, 0, 0, 3?
Yes.
Right? Is that okay?
Yes, sir.
Now, if a row like this appears, I agree that this is not in row echelon form. Convert this in row echelon form. Even then, this last row will remain the same.
By keeping k value equals to minus 2, sir.
See, if a row like this appears, that is 0, 0, 0, so on a non-zero value, such system is inconsistent.
Yes, sir.
Hello?
Yes, sir. No solution.
Yeah, no solution. Clearly, no solution means you should not take k equal to minus 2.
Okay, sir.
Or eliminate the options which say k equal to minus 2. Eliminate the option which say k equal to minus 2.
But we say the system is consistent or inconsistent by making it into row echelon form, sir.
See here, what is the choice of k minus 2, na? Hello?
Yes, sir.
Your doubt is, sir, we need to reduce this to row echelon form and then comment. Is that what you are saying?
Yes, sir.
You go ahead and convert it, na? Put here minus 2, minus 2. The last row will remain as all zeros and then 3 only, I'm saying. Hello? See
Okay,
here.
sir.
Even if you convert that to row echelon form, it turns out that the system is inconsistent. Is that clear?
Yes, sir.
That means for a choice k equal to minus 2, the system is inconsistent. But what we want is unique solution. So you eliminate D. The only option left over is B. Okay. See here, it looks like you have not understood it clearly. Okay. You are saying, sir, convert this to row echelon form. Yes, do it. Even if you do it, this last row will remain as 0, 0, 0, 3 only, which will make the system inconsistent. For that, you need to do some work. What is that work? Reduce this matrix to row echelon form. How? Like this: minus 2, 1, 1, 1, 1, minus 2, 1, 1, Anyway, this is 0, 0, 0, 3. Now what you will do is you will make this element 0, correct?
Yes, sir. 2 times
Right.
of R2
Even then what happens is this will remain as 0, 0, 0, 3. You forgot actually. I said if a row of the following form appears, that is all zeros followed by non-zero value, such system would be inconsistent. Is that
Yes,
okay?
sir. Yes, sir.
Yeah. Let me take if you have any other doubts, you can ask. Otherwise, I'll go to the next student.
Today's class, sir, when we are defining types of matrices, idempotent matrix should also be a square matrix. Sir.
Yes, square matrix only. Any other doubt?
No, sir.
Okay. Udayasri, what is your doubt?
Hello.
What is your doubt?
Sir, is there any case that determinant of a skew symmetric matrix of even order is 0?
You can create that also, but it is not always 0. You can create a skew symmetric matrix of even order whose determinant is 0, but you cannot generalize it.
Sir, in consistency, you have told that the row in echelon form should not be of the form 0, 0, 0 some alpha.
Yes.
But now we are saying that even if it is not in echelon form.
No, I'm not saying that. I'm saying that you convert that to row echelon form. Even after you convert, the last row will be remaining as 0, 0, 0, 3 only. You're not getting my point. You first thing is you did not convert that to row echelon form. Without converting that to row echelon form, you are asking me that out. You should have done some homework. Should have converted that to row echelon form. The last row will remain as 0, 0, 0, 3. Is that clear?
Yes, sir.
Is it clear or not?
Yes, sir, it's clear.
Yeah. Any other doubt?
No, sir. Thank you.
Okay. So I'll go to the next student. Ashwin Arun.
Hello, sir.
Your doubt?
Yes, sir.
What is your doubt?
Sir, actually, I have 2 doubts, sir.
You can ask.
One is today's class orthogonal matrix. You have proved some properties, sir. In that.
I have not proved any property. I highlighted some properties.
Yes, sir.
What is your doubt?
That dot products of orthogonal product of orthogonal matrix is 0. I told that, sir. So in that, like you have proved, like C1 transpose into C2 will be 0.
Yes.
Will C2 transpose into C1 will be 0? Sir?
Yes. If two vectors are orthogonal, the angle between them is 90 degrees. I mean, C2 transpose C1 is also 0. You check it if you want. Next doubt.
Every next doubt is, sir, in the properties of determinants, sir. In that you have told that skew symmetric matrix determinant of odd order means determinant of that will be 0. Can you explain the proof once more, sir? That proof.
Okay. I put the condition first of all. I'm applying the determinant on both sides. Transpose operation will not change the determinants. Okay. Because of that, this will remain as det A only. Now this is like -1 into A. So because of this, -1 whole power n into determinant of A. Okay. I took this term the other side. What is common is det A. What is left over is 1 minus -1 whole power n. Clearly, we are discussing a case where n is odd.
Okay.
When n is odd, this term becomes 2.
Okay.
So 2 times det A is 0. That means what? Det A must be 0. Utkarsh, what is your doubt?
Sir, can you please go to page 67? In which we have to find in this. So in this we had it was not given that these elements cannot be repeated. So like in this question we just took the condition that all the elements can be repeatable. So can there be a question in GATE exams that only can a question appear that a single element can appear only once?
Question I mean, we can't say what kind of question will appear.
In the sense
yeah,
that
you can expect such questions also. In such case, what you can do is you can go for verification.
okay.
If they are increasing the complexity, you also like think in a better way. You, instead of analyzing it in an analytical way, go for verification. That means take a 2x2 matrix, see what are the all possible symmetric matrices possible. So you also counterattack them.
Okay, yeah. Thank you, sir.
Okay. Yes, Yash Saxena.
Yes, sir. Sir?
Your doubt?
Sir, can you please explain the logic behind number of multiplications in the previous class you told?
Okay. See here. Order of A is m cross n. It means it has got m rows and n columns. Is
Yes.
that okay?
Yes.
Order of B is n cross p. It has n rows and p columns.
Yes, sir.
If you multiply this two, you get AB, whose order is m cross p.
Yes, sir.
How many elements are there in AB?
MP.
MP. Good. How do you get this particular element? If you can analyze, I mean, if you understand for this particular element, we are done. Are you ready?
Yes, sir.
This is the element here, second element, nth element here, correct? First row.
Yes, sir.
This is the first column of B. We take
Yes,
this
sir.
multiplied with this multiplied with this multiplied it with this, correct?
Yes, sir.
So you are multiplying actually n numbers, which needs n multiplications.
Yes, sir.
So this into this plus this into this plus so on this into this. To get this, I just used n multiplications, correct?
Yes, sir.
Like that, how many elements are there in AB?
Sir, n elements.
How many elements are there in AB?
Sir, MP.
For each element, you need n multiplications. MP elements needs MP into n multiplications.
Yes, sir. Got it. Sir, actually, I was thinking that was for the first element. And similarly, that goes for the other elements of A as well. So I thought that in a row of A, there are n elements and each element requires n multiplication. So I was doing it as n square.
No, this into this one multiplication, this into this another multiplication, this into this another. So n multiplications to get
Yes,
only
sir.
this element. Okay. Your doubt is cleared?
Yes, sir.
Yeah. Let me go to the next student.
Sir, I had just one more doubt.
Yes.
Sir, when we talk of trivial and non-trivial solution, we are referring to only homogeneous.
Yes, I said clearly that the words trivial and non-trivial we will associate only to homogeneous case.
And sir, same thing goes for linearly independent also.
Yes.
Okay, sir.
Sanjay Babu.
Hello.
Your doubt?
Sir, the last lecture, under homogeneous equations, you said there will be, of all the solutions, there will be n minus r linearly independent solutions.
Okay.
So is it only applicable to homogeneous, or is it also applicable to non-homogeneous?
It is applicable only to homogeneous.
Okay. Okay. I had
Any other doubt?
No, sir. That's all.
Sai Durga.
Yes, sir.
Your doubt?
Sir, open 79 page. Sir, could you explain that in simply way?
I have explained in simple way only. Okay, listen. You have a matrix called
Once
A.
again, I partially understand.
Yeah, I can explain you. This is the last doubt, and after this, I'll continue the lecture. If you have doubts, you write it and then ask me after 9. There is a matrix called A. We have done an operation called R3 plus alpha R1. Because of this, there are new elements here. Is that okay?
Sir.
Sai Durga, na, your name. Is that okay?
Yes, sir. Yes, sir. Okay.
So in the first step, I calculated det A using third row of A. Is that okay?
Okay, sir.
Okay, so it's like x into its cofactor plus y into its cofactor plus z into its cofactor. In the
Okay,
next
sir.
step, I calculated the determinant of B again using third row. What are the elements of the third row?
X plus alpha A,
Y plus alpha B, Z
Y
plus
plus
alpha C.
alpha, Z plus alpha.
Correct.
Yes, sir.
Interestingly, the cofactor of x here and the cofactor of x plus alpha A are same.
Okay. Okay. Okay, sir.
Cofactor of y and cofactor of y plus alpha B are same. Cofactor of
Yes,
z and
sir.
cofactor of z plus alpha C are same.
Yes, sir.
In the first
Same.
step, I have written the definition of det B. Gathered x, y, z together. How did I gather that? This whole thing into x, this whole thing into y, this whole thing into z. Gathered x, y, z together.
Okay. Okay.
In this, alpha is
Okay.
common, alpha is common, alpha is common. I have put alpha here and
Common.
wrote the remaining terms.
Okay.
This red color underlined part is nothing but det A. If you want, you check it.
Okay.
Okay. Now the blue underlined part is something like A, B, C are
B,
elements
C.
of the first row.
Is a row of first.
A, B, C
First.
are elements of the first row of A, whereas
First
the
row of
red color
Okay.
underlined ones are cofactors from the third row.
Factors of third. Okay.
So that sum of product of elements of a row with cofactors from the other row, sum of product of elements of a row with cofactors from the other row would be 0.
Okay, sir. Okay.
Yeah, that's the logic here. Okay.
Thank you, sir.
Okay.
Thank you, sir.
My dear students, I'll be dealing the doubts after 9. Please excuse me. Okay. Let's continue this discussion. And one more point I want to tell you. Tomorrow would be the last session of this linear algebra topic. I want to take the class from 4:30 to 9:30 p.m. If you have any objection, please let me know. 4:30 to 9:30. Is it okay?
Okay, sir. Okay.
Okay. Students, I just want to take the class from 4:30 to 9:30. I'll inform the manager regarding this. So he will update in the student portal, right? So if you see, your session will start from 4:30 onwards. Please cooperate for tomorrow, only if tomorrow, okay? I'll also discuss this at the end, okay? This is just a notice for you. I'll also talk at the end. Let me now continue this discussion. One of the student was talking about discuss 4x4 and 5x5 and about determinants. We will have that discussion now. Let's take a simple gate problem before that. The determinant of a matrix A is 5. The determinant of matrix B is 40. The determinant of AB is dash. Okay, it's a simple problem appeared in the gate. We know that determinant AB is det A into det B. So this gives you the answer as 5 into 40, which is 200. You can get such simple questions also in the exam. Let's see what is the logic behind this question. They gave A, they gave B, they're asking the determinant of AB minus BA. If you go by the usual way, you will end up wasting the time. What you will do is, you'll first find AB, you'll find BA, take the difference, find the determinant of that difference matrix. You'll be wasting a lot of time here, right? So instead of that, what you can do is do something like this. Understand that A is symmetric here. Check it. A is symmetric. Not only A, B is also symmetric. This element and this element. This element and this element. This element and this element are same. Okay, look at this. This element and this element. This element and this element. This element and this element. They are all same. So what I mean to say is Aij is equal to Aji. Not only that, Bij is equal to Bji. So the first observation is A and B are symmetric matrices. A and B are symmetric matrices. Let's assume that C to be AB minus BA. Let's assume C to be AB minus BA. I would be interested to take transpose on both sides. So if you take transpose, let's see what happens. So C transpose is like if you simplify, you get B transpose, A transpose. You would have studied this in your 10th class. But A and B are symmetric matrices, na? A and B are symmetric matrices. That means instead of B transpose, I can put B. Instead of A transpose, I can put A. Instead of A transpose, I can put A. Instead of B transpose, I can put B. Now, what I understand is C transpose. If you look at this, if you have to write this in terms of C, you observe this underlined part and this one. If you look at this two, you will see that the relation is simply this is minus C. So we got a condition that C transpose is minus C. So here C, or what finally I want to say is AB minus BA is a skew symmetric matrix. Of which order? Skew symmetric matrix of third order. That means what? The determinant will always be equal to what? 0. So what does this mean? This means that AB minus BA is always 0. So that is about this question. If you can crack this logic, you can actually avoid finding AB, finding BA, finding AB minus BA, and then finding the determinant of that. You have avoided all these steps. I would like to write a note point here. Look at the note point. If this is always true. If A and B are symmetric matrices, then AB minus BA is always what? Skew symmetric. So this is the logic that I have used. I have explained you the easiest way of solving this, and also I've generalized the result, which would be helpful for you. Okay, so now let's go to the next question. The next question, he says, A and B are symmetric matrices of third order, it seems. Then he says, consider the following: AB equal to BA. Second statement is AB minus BA is singular. Okay, so we will verify the first one. Right. I'll create a singular matrix like this. I'm just trying to put a counter example. So I'm just checking whether is A symmetric? Yes, it is symmetric. Is B symmetric? Of course, it is symmetric. Let me find AB. How do you find AB? This row into this column, 0. This row into this column, 0. This row into this column will give you 1. This is 0 row. 0 row multiplied with any column would be 0 only. This is also a 0 row multiplied with any column would be 0 only. This is AB. Let's find BA. How do you find BA? Very, very important. This row into this column. Okay. This row into this column, which will give you 0. This row into this column will give you 0. This row into this column, 0, 0, 1, and this is 0, 0, 0. This will give you 0. I can actually stop here. Here I have an element called 1. Here I have generated an element called 0. I can say that AB is not equal to BA. That means if A and B are symmetric matrices, then AB need not be equal to BA. But what that fellow is saying, AB is equal to BA. That means S1 is false. S1 is false. Let's look at S2. AB minus BA is singular. What is the nature of A and B? A and B are symmetric matrices. Just now we generalized the statement that if A and B are symmetric matrices, then AB minus BA is skew symmetric. So let's write a point about this. This is always true, right? S2 is true. Right now, some of the students might be saying, sir, how did you come up with a counter example? It will take some time. I also took some time to generate counter examples, right? You need to search. If the first one you get AB equal to BA, then you can't say anything about that. So you have to go for the another example like that. You have to create more and more examples. Then only you will be able to decide about S1. S1 need not be true all the time. Okay, AB need not be equal to BA all the time. So S1 is false, S2 is true. That's about this question. When you are solving this kind of questions, let me first read it, give you one hint. Let A be a square matrix of order n minus 1. Okay, usually they say A is a square matrix of order n, but this fellow says it's of order n minus 1. The elements of A are defined as Aij is n minus 1 for n equal to j. That means for principal diagonal elements are n minus 1. For I not equal to j, that means the elements which are other than principal diagonal, they are simply minus 1. What is the determinant of A? If you are dealing with this kind of values like n minus 1 or generalization, the simplest approach is verification. I want to work with a 2 cross 2 matrix. Because of that, what I will do is I'll take n as 3. If n is 3, then A would be 2 cross 2 matrix here because the order is n minus 1 comma n minus 1. So what are the entries of A? The principal diagonal elements are n minus 1. That is, this is 2, this is 2. The other elements are minus 1. This is minus 1, minus 1. What is the determinant of this? 4 minus 1, which is 3. Let's verify with option A. 3 power 2, 9 doesn't match. 3 power 1, which is 3, it matches. 2 power 1 doesn't match. 2 power 0 doesn't match. So a simple verification actually worked. Don't think too much about this. Any question which talks about generalization, go for verification of the options. Okay. Yeah. So who was the student who was talking about 4 cross 4 and 5 cross 5? Can you please raise your hand?
Yes, sir.
Yeah. Have a look at this question. All the students have a look at this question. Let A be M cross N matrix and B be N cross M matrix. It is given that det of IM plus AB is equal to det of IN plus BA, where IK stands for identity matrix. Using the above property, the determinant of the matrix given below is dash. Dear student, what is the order of this matrix?
4 cross 4.
So you are given a 4 cross 4 matrix. You are asked to find the determinant of that. So go ahead, solve it. Okay, dear students, are you there? What is your name?
Vignata, sir.
Okay, see here, if you go by the usual way, you need to expand for 3 cross 3 determinants. Okay. If you go by the usual way, you have to expand for 3 cross 3 determinants. Now listen to me carefully. You can do this in 2 ways. I'll suggest you to do in 2 ways. First method, I'll tell you. Second method, I'll upload in the notes. First method, I'll explain you. Second method, I'll upload in the notes. You can verify it. First method is the easiest one. Yeah, student, are you there?
Yes, sir.
Read this. Read this.
Make R1 as R1 plus R2 plus R3 plus R4.
This kind of operation will not change the determinant here.
Yes, sir.
We have previously discussed it, yes or no?
Yes, sir.
The determinant won't change. Can you tell me the entries of the first row now?
Yes, sir. 5.
Okay.
5, 5,
okay.
5.
Okay, I'll write the remaining entries.
Yes.
Okay, this is, by the way, not matrix actually. I'm interested in the determinant. Okay.
Yes, sir.
The properties of the determinant will allow you to put that 5 out actually.
Yes, sir.
This row has 5 in common, na?
Yes, sir. So that is equal to 5 into det of 1, 1, 1, 1.
1, 1, 1, 1. I hope this is also clear.
Yes, sir.
Now look at this. R2 is R2 minus R1. R3 is R3 minus R1. R4 is R4 minus R1. All these operations will not change the determinant.
Yes,
Do you
sir.
agree or disagree?
Yes, sir.
Can you give me the new entries?
1 1 1 1 0 1 0 0 0 0 1 0 0 0 0 1.
Now, let me highlight the principal diagonal. Below the principal diagonal, what do you see?
All 0. So it is upper triangular matrix.
Upper triangular matrix. What could be the determinant of this?
1.
1.
5 into 1. Yeah, 5.
Yeah. So what's the answer?
5.
5. See, all the time they'll make sure that there is some kind of pattern in the entries. You know what was the pattern in the entries? The pattern was if you add or if you do an operation like this, R1 is R1 plus R2 plus R3 plus R4, you get a row with all the elements identical. That is all 5s.
Yes.
Not just one time. This kind of question not repeated, not once. Every year there is a question like this. Okay, so I want to say that debt won't change. Debt won't change. Why it won't change? I have explained you. Debt won't change. Now coming to the question, he gave you some hint, that is debt of IM plus AB equal to debt of IN plus BA. If you debt of IM plus AB equal to debt of IN plus BA, if you try to crack this logic, it will take a lot of time, right? 99.99% students will not be in a position to use this and solve the question. Okay, so I'm going to upload how to handle or how to solve the question this way, right? I'll upload the notes. You can verify the notes.
Okay.
So we are done with this question. This is just a 4x4. Yeah. Can you read this question?
Yes, sir.
No, don't read it. I'll read it for you. I'll just ask you simple questions. Okay.
Okay.
It says consider a matrix called J6. Now I see there are more zeros in that and there are some ones in it.
Yes, sir.
Which is obtained by reversing the order of the columns of identity matrix I6, it seems. How did they obtain J6? Just by reversing the order of the columns of identity matrix. He's creating a new matrix called P. I'll write it here. He's creating a new matrix called P, which is I6 plus alpha J6, where alpha is non-negative real number. The value of alpha for which the determinant of P is 0. Can you just tell me any guess about the alpha value? Are you there?
Yes, sir.
Any guess?
No, sir.
No guess. Okay, don't worry at all. I'll give you activity for all the students. All the students. My dear students, can you write what is P? Okay, whoever has finished writing P can raise the hand so that I'll talk to them and write entries of P from them. Firstly, I'll lower all the hands. Lower all the hands. Whoever has finished writing P can give me the entries. So I'll be waiting for them. So how does I6 look? Yeah, Krishna Bhavane is ready. Krishna Bhavane, can you give me the entries?
Yes, sir.
Are you ready?
Yeah.
Yes.
I think, sir. 1.
1.
0.
Okay.
0. 0. 0. 0. 0.
I6 plus alpha J6. Alpha J6 means what? Here you will have alpha, 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 alpha. What is the last element here?
It is alpha.
Alpha. Give me the second row.
0.
No. Okay, sorry. 0.
0, 1.
Okay.
0. 0. Alpha.
Very good.
0.
Nice. Continue fast.
0. 0. 1. Alpha. 0. 0.
Next.
0. 0. Alpha. 1. 0. 0.
Next.
0. Alpha. 0. 0. 1. 0.
Next.
Alpha. 0. 0. 0. 0. 1.
Is this P?
Yeah.
Is this P? Okay.
Yes.
Do you want that P to be 0?
Yes.
You want that P to be 0. Can you read the first row elements of P?
1, 0, 0, 0, 0, alpha.
Last row of P?
Alpha 0, 0, 0, 0, 1.
If you can make first row and last row identical, the identical rows will give you that 0, na?
Yeah.
What could be the choice of alpha for which row 1 and row 6 are identical?
1.
What is the choice of alpha for which row 1 and row 6 are identical?
1, sir. Alpha equal to 1.
So if you put alpha equal to 1, the elements are 1, 0, 0, 0, 1. And the last row 1, 0, 0, 0, 0, 1. That means for alpha equal to 1, row 1, row 6 are identical, correct?
Yes.
Not only that, row 2, row 5 are identical. Check it.
Yes.
Row 3 and row 4 are identical.
Identical.
Whenever you have two rows or two columns identical, the determinant of that would be
0.
0. Let's write the same statement here. Okay, let's write that for alpha equal to 1, we have row 1 and row 6 identical, implies that P is what? 0. So finally, what's the answer? Alpha is 1. Now, most of the students, you know what they do? Just by looking at this 6 cross 6 matrix, they go to the next question. If you are thorough with the properties, then this is not going to be too difficult. If you can write the entries of P and if you know the properties, that will do the job. Okay, so questions can be asked like this. So questions can be asked like this. I hope everyone got this idea. Let me go to the next problem. I'll give you this as homework. You need to try on your own. Homework problem. I'll read it. The maximum value of the determinant among all 2 cross 2 real symmetric matrices with trace 14 is dash. Okay, consider a matrix called A, which is going to look like A, B, B, C. Why A, B, B, C? A, B, 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 because you need a symmetric matrix. Okay, they gave trace of A as 14. So what do you mean by trace? Trace means sum of principal diagonal elements. A plus C is given as what? 14. What are they asking? Maximum value of det A. So I want you people to try this. Okay, it's a numerical answer type question. They're asking you to find the determinant of maximum value of the determinant of the symmetric matrix. As of now, you can take a screenshot. Yesterday also what I have done, immediately right after the class, I have uploaded the notes actually. From my end, there is no mistake. So what was the problem was, they have changed our interface actually. Earlier, the faculty used to publish. Okay, now the faculty, they have not given the access. Some manager will publish the notes. So I have uploaded, but it was delayed by the other people. So today also I'll immediately upload the notes. I'll ask the manager to publish it quickly. Okay, so you can take a screenshot or you can also go through the notes. Let me go to the next problem. Okay, it's not next problem. It's about inverse of a matrix. There are few more properties on determinants. As we progress, we will learn them. It's not like all the properties are over. We are yet to discuss few more properties. Let's talk about inverse of a matrix. The first point says only non-singular matrices are invertible. Non-singular means what? Whose det is not equal to 0. Only this matrices are invertible. Let's look at how do you get inverse of a matrix. B is called inverse of A if AB equal to BA equal to I. Right? If you have a matrix called A multiplied with B, or B is multiplied with A and you get I, then B is called inverse of A and B is represented as what? A inverse. When you multiply a matrix with its inverse, obviously you'll get what? Identity matrix. Okay, so I'll just. And what is the expression for inverse? Expression for inverse is adjoint A by det A. How do you find adjoint A? Adjoint A is simply the transpose of the cofactor matrix. You all know how to find cofactor matrix. I gave you an example if you remember. I gave you some matrix called A. I calculated all the cofactors. I took your help if you remember. So how do you find A inverse? It is adjoint A by det A. How do you find this adjoint A? Cofactor matrix transpose. I'm very sorry for that. In the exam, you need not find adjoint A. Okay, to find A inverse, you need not go for adjoint A by det A. In the exam, what you can do is you can go for verification. What do you mean by verification? Verification means A into A inverse should give you I, or A inverse into A should give you I. If you have got this logic, that is enough for inverse calculations. Okay, so to make this discussion complete, what I'll do is I'll calculate one A inverse. I'll go back to one example where we calculated the cofactor matrix. I'll copy this. What are they asking in this question? Find the inverse of the following matrix. The same matrix that I took earlier also. So I'm just putting the cofactor matrix here. Remember, you will not do this in the exam, just to make the things look complete. Okay, I'm doing this activity for you. So you know how to calculate cofactor matrix? I have put cofactor matrix in front of you. So what would be adjoint A now? Adjoint A is cofactor matrix of A transpose. Let's take the transpose of this. This is -3, 6, 6. This is -6, 3, -6, -6, minus 6, 3. I got the adjoint A. I also know the det A. I know the det A because I have verified the determinants using all the rows and all the columns. So because of that activity, I know the det A. It's very fresh in my brain. That is 27. I need to look at A inverse, which is adjoint A by det A. So let's see what would be this adjoint A. So I'll write 1 by 27 out. This is minus 3, 6, 6, minus 6, 3, minus 6, minus 6, minus 6, 3. This is A inverse. I just want to go for a verification. What do you mean by verification? Verification means I want to check A into A inverse. So what is A? This is A. I'm just putting 27 in the beginning itself. Let me invite one student. Can someone help me here?
Yes, sir.
Yash Saxena.
Yes, sir.
Did I write A into A inverse?
No, sir. You wrote A inverse into A.
I wrote A into A inverse. Yeah, this is A.
Oh, sorry, sir. Actually, 1 by 20. Yes, sir. It's
thing
okay.
is I wrote 1 by 27 out. Maybe because of that you got confused.
Yes, sir. That's fine. Constant.
Is that okay? A into A inverse, na?
Yes, sir.
Acha, Yash, can you tell me what is this?
So first column of adjoint of it.
Okay. Can you repeat it again? Everyone is listening to you. Can you repeat it
So
again?
first constant of adjoint of A, the matrix.
First column.
Yes, sir.
Can you repeat it again?
So first column of adjoint of A, that is the cofactor matrix of A transpose.
Okay, listen to me. You said it's the first column of adjoint A. Am I right?
Yes, sir.
Can I also say the underlined part is the first row of cofactor matrix?
Yes, sir. We can say.
Do you agree with me or not?
Sir, I agree.
This underlined part is the first row of cofactor matrix of A.
Yes, sir.
Can you tell me what is this now?
So the first row of cofactor matrix.
What is this?
So first row of A.
A. Now you take this and multiply it with this. It's like the first row of A is being multiplied with the cofactors from the first row of A. Am I right?
Yes, sir.
What would be sum of product of elements of a row with their cofactors?
So the value of the determinant itself.
You check it if you want. This is minus 1 into minus 3. Is it 3?
Yes, sir. 3
Is it
plus 12 plus 12.
How much is that? Is it 27?
Yes, sir.
Divided by what?
27. That is 1.
1. Now, what is this part again? You tell me to the entire class.
So the first row of matrix A.
What is this?
Sir, the cofactor of first row.
No.
Sorry, the cofactor of second row.
Yeah. Cofactor matrix of A, second row, correct?
Yes, sir.
You take this and multiply with this. You know what do you get?
0.
Right? You check it. Please tell to the entire class. Do the verification for me.
So minus 6 plus 12. That comes out to be 0.
This will also be 0. Can you give me the next entries?
So the next entry will be 0 and 1 0 and 0 0 1.
Right. So what did A into A inverse give you?
So identity matrix of order 3.
Listen to me carefully. In the exam, you need not do all these calculations. What are you supposed to do? Only the verification part. A into A inverse will give you I. If you have got this logic, you can survive in the exam, right? Have this idea. So this completes A inverse calculation. I have got few more activities. Yeah. So let me show you a few more activities. Here, what are they asking us to find? says A is a non-singular matrix, then what could be the determinant of A inverse? So if you do not know this property, what happens is they'll give you A, you're supposed to find the det of A inverse. So you'll first start finding A inverse. Finding A inverse is lengthy. And after that, you have to find determinant of A inverse, so which is going to take a lot of time. Instead, what you can do is you can do something like this. We know that A into A inverse is I. Let's put det on both sides. Det of I is 1. Now det AB is like det A into det B. So what I want is determinant of A inverse, which will be 1 by det A, right? This property tells you that you don't need to find A inverse. If A is given, find det A, take reciprocal of that. So what's the answer here? The answer here is 1 by det A. I'll also explain the second point, that the remaining 2 points I'll give as homework. These 2 activities I'll give as homework, okay? Now I'm interested to find determinant of adjoint A. So now we have a relation A inverse is adjoint A by det A. So from this, what is adjoint A? Adjoint A is det A into A inverse. Let's put det on both sides. Det of adjoint A is det of det A into A inverse. This looks like this is in the form of something like this. Alpha C det. Alpha C det is nothing but what? Alpha power n into determinant of C. In the same way, this would be det A is a scalar actually. So this is det A power n into determinant of A inverse. You people know the determinant of A inverse is 1 by det A. So because of that simplification, what we get is det A power n into 1 by det A. Finally, det A power n minus 1. So the answer here is det A power n minus 1. So if you know these properties, without finding the matrix A inverse, without finding the adjoint A, you can directly comment on the determinant of that using the determinant of A. Very, very important activities. Okay, especially the first one is a regular question in the GATE exam. Okay, so if you want, you can take the screenshot of this also, because I gave some homework activity. So please take a screenshot of that. So let's go ahead with the discussion. I hope you have taken the screenshot. Now, they gave us A. They're saying B is simply A inverse. Then the element in the second row and third column of A, sorry, I read it wrong. Then the element in the second row and third column of B is dash. First thing is, they gave B equal to what? A inverse. In this problem, you need not find all the elements of B. Find only that element which is asked in the question. What is asked in the question is B 2, 3. So look at the way how I'm going to solve this. B is simply adjoint A by det A. How does adjoint A look like? Adjoint A like this. cofactor matrix of A whole transpose. For example, imagine the cofactor matrix is like this. Okay, cofactor matrix is like this. I'll also try to put adjoint A. I would be interested in the element belonging to the second row and third column of adjoint A. Second row and third column, that is this. How do you get this element? You know, we get this element, right? 2 B 2 3 na, so 3 2, that is this. I need to find this particular element. Once I find this particular element, after the transpose operation, this goes and sits here. Right, so what actually I need to find is cofactor, this particular element. To get this, I need to find this, because after getting cofactor, there is an operation of transpose. So first thing is find cofactor of A32. What would be the cofactor of A32? Cofactor of A32 is -1 whole power 3 plus 2 into a minor. So what could be that minor? What are the entries in that minor? 3 2 na. So third row, second column I need to hide. So if I hide 1 0 1 1 1 0 1 1, so how much is this value? This is -1. Similarly, I need det A. I need det A. So how do you find det A? I'll use the third row to expand det A. 0 into its cofactor plus 0 into its cofactor plus I'm using the third row to expand the det. Okay, 1 into -1 whole power 3 plus 3 into a minor. So what could be the entries of that minor? 1 -1 1 1. So how much is this? This is 2. Now B23 is simply this particular element divided by det A. What is this particular element? This particular element is same as this element, that is -1. So it's -1 divided by 2. So this is how you find it cleverly. Okay, what is required? If you find that, you can save some time. Whatever is required, you try to find that. This completes this question. Okay, so there is one trick here. If you want to find element belong, like this question is about A inverse, they're asking what is the second row third column element of A inverse. So I did it in a sequence. I wrote expression for A inverse, wrote what is adjoint A, I wrote cofactor matrix, and I highlighted what are the things that are going to happen here. I hope you understood this. My dear students, at any point of time you have doubt, my sincere advice is write the page number. See here, the page numbers are available here. Okay, see here, page numbers. Write that page number and quickly write what is your doubt, so that in the doubts session time you can ask me. Okay, so let's solve this question which appeared in 2019. This is to tell you again and again that if you have a basic idea about A inverse, you can survive in the exam. Utkarsh, are you there?
Yes, sir.
Can you read this question, Utkarsh?
Sure. consider a 2 cross 2 matrix. I am equal to matrix of vector v1 and v2, where v1 and v2 are column vectors. Suppose M inverse is a column vector of u1 transpose and u2 transpose.
No,
where
don't
you
read like that. You need to read like this. M inverse is
U1
transpose, u2 transpose.
Okay, yeah.
Where what are u1 transpose and u2 transpose?
They are the row vectors.
Yeah, continue.
Consider the following statements. Statement 1 as u1 transpose into v1 equals 1 and u2 transpose into v2 equals 1. And statement 2 is u1 transpose into v2 equal to 0 and u2 transpose into v1 equals to 0. Then which of the following options is correct? Statement 2 is true and statement 1 is false. Both are false. Yeah.
Yeah. You need not read it. Okay. Do you know any condition about inverse?
Yeah.
What is that condition that you know about inverse?
Condition as in
like any, I said you can do verification. Now, what kind of verification you are going to do?
A matrix with its inverse, like multiplication of a matrix with its inverse gives identity matrix.
Okay.
Let
me read. Let me read. So will this also be equal to M inverse into M equal to I?
Equal to 1. Yeah, equal to I.
Yeah. Okay. Let's also talk to Krishna Bhavane. Yeah, Krishna Bhavane, I hope you are understanding the things. Krishna Bhavane.
Yes, sir. Hello.
Yeah. I hope you are understanding the things.
Yes, sir.
Can you tell me what is M given?
U1 transpose.
M is given as V1, V2. What is the nature of V1 and V2?
V1 and V2 are column vectors.
Okay, so that means you have to imagine something like this. Okay, this is M. How does M inverse look like?
U1 transpose.
U1 transpose. U2 transpose. What is the nature of U1 transpose and U2 transpose?
They are row vectors.
They are row vectors. Is it given in the problem?
Yeah.
Yes or no?
Yes, sir.
Now, can I use something like this? M inverse into M, will it give I?
Yeah.
What is M inverse given?
U1 transpose. U2 transpose.
U2 transpose. What is M given?
V1, V2.
I need to write it like this, like as given the question. Is the nature of U1 transpose this complete one? Is it like a row?
Yes, sir.
Is it like a column?
No.
I can multiply a row with the column, na?
Yes, sir.
Now when I do that, I need to get I because M inverse into M should give me I, correct? Yes or no?
Yes, sir.
Is this a row?
It's row.
Yes. Is it a column?
Yeah.
Yes. So you know what I get is something like this. U1 transpose V1 should be equal to 1.
Yeah.
Okay. Again, help me out. Is U1 transpose a row?
Yes, sir.
Is V2 a column?
Yes, sir.
This row into this column, that is U1 transpose V2 should give me what?
0.
Okay. Now, is U2 transpose a row?
Yes, sir.
Is V1 a column?
Yes, sir.
This row into this column, that is U2 transpose V1 should give me 0.
Yes, sir.
Now the last calculation. This U2 transpose is like a row. V2 is like a column. This into this, that is U2 transpose V2 should give me what? 1. Now look at statement 1. U1 transpose V1 is 1. U2 transpose V2 is 1. Do you agree with that?
Yes, sir. Statement 1 is wrong.
Statement 1 is absolutely true.
Yes, sir. Yes, sir.
Statement 2. U1 transpose V2 is 0. U2 transpose V1 is 0. Yes. So it looks like statement 1, statement 2, both are true. Both are true. Okay, my dear students, you might be asking, sir, why did you take M inverse into M? You could have taken M into M inverse also. If I take M inverse into M, then the first step itself, row times column is possible. Row times column axis is there if you take M inverse into M. If you take M into M inverse, you will not get that ease. Okay, that's the reason why I took M inverse into M equal to I. This appeared in 2019 GATE. Very simple problem. If you stick with M into M inverse in equal to I, it will take a lot of time for you to crack that. Instead, if you go by M inverse into M, that is row times column, matrix multiplication is row times column. So if you go by that logic, you get the answer in a quick time. So that is about this question. So let me go ahead with the discussion. This is one more question which appeared in 2019. The inverse of the matrix is dash. You need not find all the entries here. We'll go for verification. What do you mean by verification? See here. Whichever option gives me A into A inverse as I, that would be my answer. A into A inverse should give me what? I. A inverse into A should give me I. That's it. So I'm just taking this. I want to do the verification part. Okay. Now I'll go with option A. I'll not find all the elements. I'll just verify with the first column. Let's see what could be the first element. This is row. This is column. How much? Minus 20. Minus 20 plus 45 minus 20. So here I get 5, but what I should have got is 1. This is wrong. Go to the second option. Elements are 2, minus 3, 1. I wrote the first column and I don't care about the other ones. Take this, multiply it with this. 4 minus 9 plus 4, which is minus 1. I should have got 1, but there is an element called minus 1, eliminated. Let's go to C. I'll just pick the first column, minus 2, 3, 1. So let's look at the option. Minus 4 plus 9. Achha, this is also minus 1. Minus 4 plus 9 minus 4, which is 1. This might be the answer. Okay, this might be the answer. I'll go for another verification, that is option D. 10 minus 15, 5. What I get is, this is row, this is column. 20 minus 45 plus 20. I get minus 5. That means this is also gone. This is the right answer. So this kind of verification will work in the exam. Some of you might be asking, sir, what if here I get 1? Instead of 5, if you get 1, then go for the next element here. Go for the next element, right? In the GATE exam, mostly what they'll do, they'll create the problems based on properties. If you know that A into A inverse is I, just do this kind of verification, you'll get the answer. Okay. So what they want is they just want to check how well you are good with the properties. So the answer for this question is option C. We are done with A inverse and their properties. I gave some homework activity also. I'll remind you again. You are supposed to find what could be the expression of adjoint A. What is the determinant of adjoint A? These are the homework activities. The most important discussion of today's session. One is about determinants, the other is about rank. I remember yesterday when I was solving system of linear equations, there was one student. I was saying rank, suppose if a matrix is in row echelon form, rank is simply the number of non-zero rows, right? He had some issue saying, sir, you did not define rank. You are using that in the first class itself. Okay, see, you have covered rank in your 11th and 12th standards, yeah. So you people should be so quick. You should learn the things on the fly. Okay. Right now, we will have a detailed discussion on what is rank of a matrix. So I'm especially telling that particular student yesterday who has asked me about the rank. Right now, we will have a detailed discussion on rank. Who was that student? Raise the hand. Who was that guy? Is he not there? Okay. I'm not going to scold you anyway, don't worry. So let's have a discussion on rank of a matrix. There are many statements about the rank. I'll try to explain them one by one. Okay. So Aditya Deshpande, are you there?
Yes, sir.
Can you read the first point?
Rank of A denotes the number of non-zero rows in any row echelon form, that is row equivalent to A.
Everyone is aware of this, na? Rank of A is simply the number of non-zero rows in row echelon form of A. Is that okay?
Yes, sir.
Right. There is no doubt in this. Can you read the second one?
Rank of A denotes the number of pivots obtained in reducing A to row echelon form with row operation.
Once you reduce that to row echelon form, rank of A is also equal to the number of pivot elements, it seems.
Yes, sir.
Okay, number of non-zero rows in row echelon form would be same as number of pivot elements. Is that also clear?
Yes, sir.
Did we discuss problems on this?
Yes, sir.
Okay. Now comes third and fourth point, which I'm going to discuss in a detailed way. Read the third and fourth points.
Rank of A denotes the size of the largest non-zero minor of A. Fourth point. Rank of... Okay.
Yeah, read it.
Yeah. Rank of A denotes the number of linearly independent rows or columns of A.
See, point 3.4, you may not be understanding right away. I mean, let's say it will take some time. Point 3.4, I mean, if you want to understand, it will take some time. What I'll do is I'll take some examples. So while explaining the fourth point, I'll talk about linearly independent vectors concept. Linearly independent vectors concept. Okay. So after discussing linearly independent vectors concept, I will also go through two problems that I have left. You remember those two problems? I said we will discuss that after discussing linearly independent vectors. Okay, so now our focus is on understanding third and fourth properties. Once again, you read the 4 points, Deshpande.
Rank of A denotes the number of linearly independent rows or column of A.
4 points.
Okay. Rank of A denotes the number of non-zero rows in any row echelon form, that is row equivalent to A. Rank of A denotes the number of pivots obtained in reducing A to row echelon form with row operation. Rank of A denotes the size of the largest non-zero minor of A. Rank of A denotes the number of linearly independent rows or columns of A.
We will now talk about the third point. Okay, we will focus on the third point. Rank of A denotes size of largest non-zero minor. Okay, so let's focus on this. To help you people understand the third point, I have taken one example. That example is use determinants to compute rank of A. Okay, use determinants to compute rank of A. Let's talk to Munir Hussain. Hussain, are you there?
Sir.
Hussain, can you tell me what is the order of the matrix A?
3, sir.
What 3? Our order means you tell me number of rows, number of columns.
3 rows and 4 columns.
Then you are simply saying 3.
Yes,
It might be you thought of A as square matrix, na?
Sir.
Yeah, it's not square matrix. Can you read this question again?
Use determinants to compute the rank of.
Can you readily apply the determinant on A?
No, it's not a square matrix.
Yes, it's not possible. But this fellow says use determinants to find the rank, na? Okay, listen to me carefully. Everyone, Hussein will answer. The other students will help Hussein. Hussein, delete the last column of A. Give me the entries.
1, 2, 3, 4, 5, 6, 7, 8, 9.
Okay. Delete the third column of A.
1, 2, 3.
Third column is deleted.
1, 2, 1, 4, 5, 1, 7, 8, 1.
Okay, nice. Delete the second column.
1, 3, 1, 4, 6, 1, 7, 9, 1.
Delete the first column.
2, 3, 1, 5, 6, 1, 8, 9, 1.
Now, whatever matrices that you see, are they square matrices?
Yes, sir.
Hussein, can you please find what is this determinant? Other students, if you are ready with your answers, please raise the hand. I'll take your answers. Hussein will find the determinant of the first one. The remaining students, if you are ready, you can also answer it. Hussein, don't be like tensed. Okay, do it at your pace. Relax.
Okay, sir.
I want all the students to find this determinants. Vishnu?
Sorry, sir.
Yeah, what do you want to say?
Sir, the first determinant is 0, sir.
Okay, what about the next one? Can you help me with the next ones?
Yes,
take your time. Take your time, find it. Hussein, Vishnu says that it is 0. Do you agree or not? Check it. I also agree with Vishnu answer.
Sir, I got 6.
No, you have to verify it again. Others, if you are done, please tell us. Vishnu, what?
Yes, sir. Sir, all the values are 0, sir.
All the values are 0. Okay, I'll take suggestions from the other students also. Vishnu says all the determinants are 0, it seems. Okay. Uday Sri, what do you want to say?
All are 0, sir.
All are 0. Okay. Yash?
It's the same thing. All are 0.
All are 0. So Munir has to correct. Krishna Bhavane?
Sir, all are 0.
Okay. Indam?
All are 0, sir.
Okay. Nice. So
Got it, sir.
this much of verification is enough. So I see that most of the students said all the determinants are 0. Okay. So I'll write that this is 0. This is 0. This is also 0. Actually, I'm looking. You know what? These are all minors. It's a 3x3 minor. Minor means what? It's a determinant of a square submatrix. This is also a 3x3 minor. This is also a 3x3 minor. This is a 3x3 minor. Hussein, are you there?
Yes, sir.
Hussein, all the 3x3 minors, are they 0?
Yes, yes, yes.
Actually, if you read this third point, can you please read this third point?
Rank of A denotes the size of the largest non-zero minor of A.
What I want is not 0 minor, but what I want is non-zero minor. Okay. All 3x3 turned out to be 0 or not?
Yes, sir.
Now, look at this. Can I call or can I take these elements and find a minor?
Yes, sir.
Yes, I can do that because minor is simply what? It's a determinant of a square submatrix. What is the value of this?
A minus 8. Minus 3.
Is it equal to 0 or not equal to 0?
Non-zero.
What is order of that minor?
2.
Therefore, rank of A is 2. Is that clear?
Sure.
Now, there would be many doubts from the students. What they'll say is, sir, what if one of the 3x3 minor is non-zero? Okay, for example, if this turned out to be non-zero, okay, and the 2x2 minor is also non-zero, then which would be the rank? The rank would be 3. The rank would be 3 because, can you please read this sentence?
Size of the largest non-zero.
Size of largest non-zero minor. That means among 2x2 and 3x3, which is the largest in terms of size? 3x3. So the rank must be 3. But here the problem was all the minors turned out to be what? All the 3x3 minors turned out to be what?
0.
0. So the rank cannot be 3. Okay. Now,
Oh.
you may get a doubt, sir. What if all 2x2 minors are 0? If all 2x2 minors are 0, the rank is 1. Is the point clear? Hussein?
Yes, sir.
If
Yes.
all 2x2 minors were also 0, the rank is how much?
1.
Okay. So this is about the third point. Rank of A denotes size of largest non-zero minor of A. Okay. So this is about this. In the exam, no one will use this logic to find the rank. You know, I'll ask Hussein one question. Hussein, what is the easiest way to find rank of a matrix?
Easiest by that
Row echelon form.
row echelon.
Reduce the given matrix to row echelon form.
By and finding the number of non-zero rows. Or finding the pivot elements.
That's what, both are same only. Reduce the given matrix to row echelon form. Count the number of non-zero rows. I hope you people have understood this. Okay, so you can mute. I'll go ahead with the discussion. I've got few more properties. See, maybe I'm running out of the time. What I'll do is this particular fourth point I'll discuss tomorrow. So tomorrow we'll start with linearly independent vectors concept. Okay, this fourth point I have to explain you nearly for more than 30 minutes to 1 hour, 30 minutes to 60 minutes. It will take that time. That is very, very important concept. So right now what I'll do is I'll stick with properties of rank. So the first property says the rank of M cross N matrix is always less than or equal to min of M comma N. Always equal to what? Rank of a matrix is less than or equal to min of M comma N. The second property says the rank of A plus B is less than or equal to rank of A plus rank of B. These are not easy to prove. Okay, if you remember this, it would be helpful for you in the exam. Okay, if rank of if A is M cross N, B is N cross P, where matrix multiplication is possible between A and B, rank of AB is less than or equal to min of rank of A comma rank of B. The next property, okay, appeared in the GATE exam. Multiple times. So what is that property? Rank of A into A transpose same as rank of A, which is also rank of A transpose into A. So if you already know the rank of A and they're asking you about rank of A into A transpose or rank of A transpose into A, that would be equal to what? Rank of A. The next property is the rank of a non-zero matrix is non-zero. Okay, it cannot be zero. Suppose you have a non-zero matrix, the rank cannot be zero. By default, rank of a null matrix is taken as zero. Rank of a null matrix is taken as what? Zero only. The rank of a non-singular matrix is its order. What do you mean by a non-singular matrix? Non-singular matrix means whose determinant is not equal to zero. Suppose you are given a square matrix, you calculated its determinant, the determinant is non-zero, you can declare that the rank is its order only. Suppose you are given a singular matrix. The rank of that matrix for sure would be less than its order. The rank of a singular matrix for sure would be less than its order. Very, very important ones. I'll also use this while solving eigenvalues and eigenvectors. I want someone to read it again. So let's. Usha, Maunika, can you read all these properties?
Yes, sir. Let A be M by N matrix. Rank of A should be less than or equal to min of M by M and N. Rank of A plus B is less than or equal to rank of A plus rank of B. If A is of order M by N and B is of order N by P, then rank of AB should be less than or equal to minimum of rank A, rank B. Rank of A transpose is equal to rank of A and rank of A transpose A. The rank of a non-zero matrix is always non-zero. The rank of a null matrix is zero. The rank of non-singular matrix is its order. The rank of singular matrix is less than its order.
What is non-singular matrix?
That A is not zero, sir.
So whenever the determinant is not equal to zero, the rank would be its order. What would be the determinant of a singular matrix?
Zero, sir.
What would be the determinant of a singular zero? You are right. What would be the rank of a singular matrix?
It would be less than its order, sir, but we can't tell its value.
Yes, it would be less than its order. Correct. Nice. Okay, so this property, that is second property, this and this are very, very difficult for you to prove. You can understand the first property by solving the examples, but the remaining properties are very, very difficult. Okay, so I don't ask you to go through the proofs also, just to remember them. Right, there were no questions on this properties. There were questions on rank of A into A transpose equal to rank of A. Okay, so this property is very, very important. Let me put some questions in front of you now. I have 10 more minutes. I would like to solve few questions. Now there is one more term called nullity. In our workbook especially, there is no mention of the word nullity so far in the GATE exam. But in some textbooks, especially let's say for our A's workbook, they'll use the word called nullity. Nullity is simply the difference of order and rank. So if order is n, this is defined only for square matrices, by the way. Only for square matrix. Right? Let's say A is a square matrix of order n. Nullity is simply n minus r. N minus r. The nullity of a non-singular matrix would be n minus n, which is 0. Right? This is for what? Non-singular matrix. So this term actually, whenever you solve some problems in workbook, you'll get the term called nullity. It is simply the difference between the order of a square matrix and its rank. Okay, so these are the interesting points about the rank. The easiest way to find the rank is to reduce the given matrix to row echelon form. Okay, now I'll use this remaining 10 minutes to solve the problems, and after that I'll handle the doubts. What he says is, let A is a matrix. If rank of A is 1, then what could be the value of P? Just through inspection, by inspection, I'll just put P equal to 3. So what happens here is I get 3, 3, 3, 3, 3, 3. Now I can use operation like this. What happens is you get something like this. This is not A. Gets simplified to 3, 3, 3, 0, 0, 0, 0, 0, 0. Clearly rank is 1. That means what's the choice of P? P must be 3. So just by inspection, okay, just by looking at the entries, you can answer this question. Let's look at another question. I just used a couple of minutes left over to solve some problems. Suppose that A n cross n is upper triangular matrix such that AII, whenever he uses AII, he's talking about principal diagonal elements. He's creating an upper triangular matrix with all the principal diagonal elements 0. He's asking what could be the rank of A power n. This also comes under the question of generalization. The best thing is verification. What kind of verification? I'll go with n equal to 2. I need to create an upper triangular matrix. Already they gave an information that AII is 0, it seems. So this is 0. This is also 0. Since it's upper triangular, this element is also 0. Right? I just want to put some element called 1 here so that it will not become null matrix. I created one example which is going to satisfy the conditions given in the question. What I need to do, I need to find rank of A square. For that I need A square. Let's do the matrix multiplication. This is row. This is row, this is column. So I get 0. This is row, this is column 0. This is row, this is column 0. Row into column 0. I got A square as null matrix. That means rank of A square would be 0 because null matrix rank is 0, na? So which option satisfies that? A satisfies. 2 minus 1 is 1. This doesn't satisfy. This also doesn't satisfy. This also doesn't satisfy. Whenever a question is on generalization, you can use this logic. Okay, so this is about this question. I'll go to the next question. Okay. Let me read the entries here. Let A be a matrix. it's a 3 cross 3 matrix where A, B, C are non-zero real numbers. Clearly, A, B, and C are non-zero numbers, it seems. What is rank of A? My observation goes like this. This is A and this looks like minus A. That's fine. This is B and this looks like minus of that. This is C and this looks like minus of that. That means this matrix is satisfying a property of Aij equal to minus Aji. Clearly, A is a of order 3. So what we know is if it's a skew symmetric matrix of order 3, the determinant of that will go to 0. Now when the determinant of this matrix is going to 0, the rank is not its order, actually it's less than its order. So rank of A is less than 3, right? So you can eliminate this option called D. The rank is less than its order. So how do you tackle this from here onwards? What I'll do is I'll go for a minor like this. It is 0, A, minus A, 0. What is the value of this? This is, I think, plus A square, which is not equal to 0. How do you know that this is not equal to 0? I know it because A, B, C are non-zero. A, B, C are non-zero. A square is also non-zero. Therefore, rank of A is 2. Rank of A is 2. Option C is right. Okay, maybe I have time to solve one more question. I'll solve this question and then I'll stop the discussion. What is order of this matrix? How many rows? 1, 2, 3, 4, 5. How many columns? 5 columns. What are they asking? They are asking us to find rank. The best way is use the row echelon form. So what I'll do is I'll start the analysis like this. R5 is not R5, I'm sorry, R4. R4 is R4 plus R1. Let's see what could be the entries. And also I want to interchange row 2 and row 3. Right, row 2 and row 3 I want to interchange. Why I want to interchange is to make this look like or convert this to row echelon form. Now R4 is R4 plus R1. Add them 0, add them minus 1, add them 0, add them 0, add them 1. Row 5 is unchanged. What can be done? Using this, make this 0. So how do you do that? R4 is R4 plus R2. You people also try. Let's verify our answers. R4 have to change. I have to add R4 and R2. 0, 0, adding minus 1, adding 0, 1 plus 0, 1. Couple of calculations. So this would be asked for 2 marks in the exam. Now use this element, make this 0. R4 is R4 plus R3. Let's go to the next page. Students, don't go away. We will talk about tomorrow's class timings after this problem. My dear students, please don't go away. We will talk about tomorrow's class timings. So what do we get? What do we get is 0, 0, 0, minus 1, 1. Now using R4, I have to make R5 0. R5 is R5 plus R4. So what do I get is and the last row turns out to be entirely 0. The last row turns out to be entirely 0. Now this is in row echelon form, therefore the rank of A equals the number of non-zero rows, which is 4. Okay, first let me confirm tomorrow's class timings and then I'll take the doubts. Some of the students have, I requested, I need some additional time. So I asked 4:30 to 9:30, is it okay? Some students said, better you take from 4 onwards. So you people, please let me know. So students, is 4 to 9 okay?
Yes, sir.
Students, please reply me.
Yes, sir.
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
Okay, sir.
So I'm
Yes, sir.
confirming.
Yes, sir. Is it okay?
Yeah. So I'm confirming this with the manager. He will upload, he will, do the modifications, the required modifications. You will see that the session is going to start from 4 onwards. And also most of the students, I think by now you are in the Telegram. If you have any problem regarding this, you can message me in the Telegram. You can put it in the group only. If you are from ECE, you can put in ACE ECE. If you are from mechanical, ACE mechanical, you can ask your doubt regarding the class timings. So we are there to help you. So don't worry about that. So I'm confirming this, that is from 4 p.m. to 9 p.m. 9 p.m. to 9:30 or 9:45 or whatever it is, you will have a doubt session. So tomorrow this linear algebra would be over. Now, what I'll do is I'll first lower all the hands. One by one, you can ask me the doubts. Yes. So Deshpande, what is your doubt? Deshpande, what is your doubt? Aditya Deshpande.
Hello, sir. In the homework question, the determinant of adjoint of A, sir.
When I say that is homework.
No, sir. The previous one, sir, not that slide, sir.
Which one?
Determinant of adjoint of A.
Determinant of?
Adjoint of A, sir.
When did I give that homework?
Not homework, sir. In that slide, there are homework previous second one, sir. You third and fourth.
Yeah, I got your doubt. Yeah, I got your doubt. Sorry. You are asking about determinant of adjoint A, correct?
Yes, sir.
Yeah. What is your doubt?
After determinant of determinant A, sir. After that, can you explain, sir?
Which one?
Yes, sir.
See, first of all, what is determinant of A inverse?
Hello, sir.
What is the determinant of A inverse?
1 by determinant of A.
Okay. What is expression for adjoint A? Can I say, if I send this term the other side, adjoint A simply det A into A inverse, na?
Yes, sir.
Is det A a scalar?
Yes, sir.
Is A inverse a matrix?
Yes, sir.
What is the determinant of alpha C, where alpha is a scalar, C is a matrix?
Oh, alpha to the power of n.
Correct. That is clear, na?
Yes,
Here,
sir.
is det a scalar?
Yes, sir.
Is A inverse a matrix?
Yes, sir.
Let's put determinant. What is determinant of det A into A inverse? Will it be det A power n into the determinant of A inverse?
Yes, sir.
Now we know the determinant of A inverse is 1 by det A.
Yes, sir.
So simplifying this will give you det A power n minus 1.
Yes, sir.
Yeah.
Sir, another thing, sir, you refer the columns as vectors. Why do we do that, sir?
You can refer the columns as vectors, rows also vectors. It doesn't matter.
So vector
But
rows
the
are also.
terminology we use in our textbooks are everywhere. The authors call like that. Column usually we call column vectors, row vectors, na?
Yes, sir.
So
That
don't
is,
get
sir,
confused with that.
Simply naming, no, sir.
Yeah.
Yep, okay, sir. Thank you.
Krishna.
Yes, sir.
Yeah. What? And one more suggestion to my dear students: you have opted for online class. When you have opted for online class, this online class is going to be for, let's say, 6 months or so on. In all this, you will be talking to the faculty. Make sure you have got good earphones with a good mic. Okay, you have spent a lot of money. Just spend some more. Make sure that you have got a good mic and also a peaceful environment. Because whenever you ask something and if it is very noisy, it is going to be your loss. Okay, so make sure you have got good headphones or make sure your environment is so peaceful. Yeah, Krishna, what is your doubt?
Sir, in skew symmetric matrix, the diagonals are 0. So how they are 0? Please repeat.
What's the condition for skew symmetric matrix?
A transpose equal to minus A.
What is the other condition?
Other conditions, det of A equal to 0.
No. Other conditions means this is the other condition. Okay, Aij equal to minus Abi, correct?
Yes.
Principal diagonal elements means I and j are equal. Na? See here, A 1 1 1 and 1 are same here. 2 2 is there. 3 3 is there. Correct?
Yes.
So for principal diagonal elements, I can say I equal to j.
Yes.
Put I equal to j in this case. What happens? Read it now.
Ai equal to minus Ai.
Is there any number which is equal to negative of that?
No.
There is one number that is 0. 0 is same as minus 0.
Yes, sir.
Yes, that means what? Aii must be equal to what? 0.
0.
That means principal diagonal elements must be all zeros.
0. So another route, page number 66.
Page number
66.
Sir, in this problem, I understand that's principal diagonal plus above principal diagonals addition. But sir, how we got that answer?
Okay, how we got about q power n square? You are talking about this?
Yes, sir. Yes, sir. That I understand. Q power. But sir, how we take q power n square plus n by 2?
I tell you. See here. This is called counting principles. You would have studied in probability. If one experiment results in m possible outcomes, another experiment results in n possible outcomes, then you will say there are m into n possible outcomes of the two experiments. Okay?
Yes, sir.
You can fill the first element in q ways, second also in q ways, so on all n square plus n by 2 in q ways. So it's like q multiplied with q multiplied with q, n square plus n by 2 number of times, n square plus n by 2 number of times. So when you multiply q that many times, you get q power n square plus n by 2.
Not understand.
Okay, you are not able to understand. See here, if you have 2 pants with you,
okay,
4 shirts with you, and I ask you in how many different ways you can wear, what will you answer?
4 into 2.
Huh?
4 shirts and 2 pants.
Huh.
That 4 into 2, no, sir.
4 into 2, na? Yes or no?
Yes, sir. Yes, sir. Yes.
So you used multiplication there.
Yes, sir.
In the same way, the first element here, it's filled, or it can be like, this can be filled in q ways actually. This also in q ways. This also in q ways. So the total number of ways would be the product actually.
Okay.
Is that okay?
Yes, sir. Yes, sir.
Yeah.
Sir, another doubt in rank, sir. Properties of rank.
Okay.
Sir, we take rank of A plus B equal to rank of A plus rank of B, less than or equal to rank of A plus rank of B.
Yes.
Sir, if say, rank n into n cross n matrix, that is its order is 4 into 4. Rank matlab A plus B rank has 4 into 4. And matrix A also rank matrix A also 4 into 4 and matrix B also 4 into 4. And sir, if rank of A plus B, suppose let's 3, and rank of A comes 3 and rank of B also comes 3. Then
So
sir,
now
3 plus 3, 6.
3 is less than 6, na?
Yeah.
So what are we saying is, we are just saying this has to be less than or equal to that.
Okay.
Rank of A plus B is less than, or it can be equal to rank of A plus rank of B, but it cannot be greater than that. I don't understand your, what is your doubt?
Sir, I think less than or equal to, na? Then I think rank of A plus B equal to rank of A plus rank of B.
See, you are just reading that property, you are not telling your doubt.
Sir, I thought rank of A plus B in some cases equal to rank of A plus rank of B.
Yes.
Then in what cases, if I got rank of A plus B is 3, and if I got rank of A is separately 3 and rank of B also I got 3, then 3 plus 3 is 6. That
okay.
The confusion.
See here, I'll give you want a case where rank of A plus B is equal to rank of A plus rank of B, correct?
Yeah. Yes, sir.
Okay. Let A be I. B be null matrix.
Yes, sir. Yes, sir. I got it.
Yes,
thank
you. Yeah.
Sir, page number 59.
59. Your doubt?
Sir, by randomly checking any 2 columns, page number 59, sir. Orthogonal.
59
Orthogonal.
I have opened.
Yes. By randomly checking any 2 columns, if we get that those 2 columns are perpendicular, then can we say that the matrix is orthogonal?
No. Can't say that.
Okay, sir.
Just by checking the 2 columns, the other way is not true.
Okay, sir.
Any other doubt?
No, sir.
Ashwin, what is your doubt?
Sir, page 94, sir. Previous one.
This one?
Before.
What is that related to?
The same question, sir. You are solving the same question.
Which question?
Sir, previous question.
This one?
Yes. You were solving steps. Yes, sir. In this last step, I didn't understand how it came how the determinant you told that as 1.
See here, below 1, what do you have?
0, sir. Full zeros.
Below this one, what do you have?
0.
Below this one?
0.
That means it's an upper triangular matrix.
Yes, sir.
For upper triangular matrix, the determinant is product of principal diagonal elements.
Oh, yes. Okay, sir.
Yeah.
Got it. Thank you, sir.
Vishnu, what is your doubt?
Sir, I'm having a 3x3 matrix, sir. Sir, in that I am performing one operation. R2 implies R1 plus R2 plus R3. Sir, then can I perform the same operation for row 3? That which means R3 implies R1 plus R2 plus R3. Can I perform the same operation for 2 rows?
See, I'll just write it. Yeah, tell me what you want to do. There is a matrix called A. There are
It's
3
a
rows.
3x3 matrix, sir.
Okay.
I'm performing R2 implies R1 plus R2 plus R3.
Okay.
So can I perform R3 also as R1 plus R2 plus R3?
You have to do it in a stepwise. Okay. First do R2 replace with R1 plus R2 plus R3, and after that you get a new matrix. Again, replace R1, R3 as R1 plus R2 plus R3.
So, but we cannot perform it in same step.
Why you want to perform the same step? Why you want to do that? Is there any reason?
No, sir.
Then what is the use of that? You see, you have to do in a stepwise because R2 is changing, na?
Yes, sir.
Then
okay.
You do it in a sequence.
Okay, only after changing R2, I will be able to change R2. Okay.
With the same, let's say, right hand, you cannot write on. I mean, it's like you can't do it simultaneously. One after the other only you can do.
Sir, why I asked this doubt was if we perform this 2 operation in single step, we will be getting determinant 0, sir. We will be getting 2 identical rows.
That's what maybe you will get. No. That's what I'm saying. See, you have to do it in a sequence. First, do R2 replace with R1 plus R2 plus R3.
Okay.
And then after
I understood,
that,
sir.
If you do it like this, every matrix determinant would be 0 then.
Yes, sir. Thank you, sir.
Okay. Pavan Kumar.
Sir.
Yes. What is your doubt?
Sir, ఒకసారి homogeneous system చెప్పండి సార్.
ఏంటి మీ డౌట్ ఏంటి అందులో?
సార్ homogeneous system లో ట్రివియల్ కి నాన్ ట్రివియల్ కి అర్థం కాలేదు.
Okay. You are having confusion in trivial and non-trivial. Okay.
Yes, sir.
See here, trivial means there is only one solution. Trivial means there is only one solution, and that solution is all these variables equal to 0.
Okay, sir.
Is that okay? Non-trivial solution means I'll try to explain by taking one example. Look at this. Pavan, are you there?
Yes, sir.
In all these equations, put x1 equal to x2, so on equal to x5 equal to 0. Will that satisfy?
Yes, sir.
Okay. I wrote a general solution here and I have taken k1 equal to k2 equal to 1. With that, I got some solution that is -4, 1, -1, 1, 0. Is that okay?
Okay, sir.
This is non-zero solution. Why am I saying non-zero? Because at least one of the variable is non-zero. Do you agree or disagree?
Agree, sir. Yes, sir. 4 ఉన్నాయి కదా sir.
Yes. That means this kind of solution is called a non-trivial solution.
Okay, sir.
Okay. Now,
okay, sir.
If you change k1 and k2 values, do you get new solutions?
Yes, sir.
All those solutions together are called non-trivial solutions.
Okay, sir.
Okay.
Okay, sir.
Any other doubt you have?
Sir, మీరు ఈక్వేషన్ చెప్పారు కదా సార్ నాన్ ట్రివియల్ సొల్యూషన్ అని.
Which one?
అంటే xf1 h1 plus xf2 h2 అది నాన్ ట్రివియల్ కి సార్ అది?
Yes.
Okay, okay, sir. Okay, sir.
Yeah. Arun, not Arun. Arul Peter.
Hello.
Yes. Your doubt?
Sir, I asked a question in the question and answer section. Can you please see?
That question and answer I am unable to see. You please tell me what is your doubt. Otherwise, I would have seen that. Na?
Okay.
Actually, yesterday also there was some problem with that question and answer. When I scroll down, I am unable to see the question.
Can I tell the question, sir?
Yeah, you can tell. See, this is the best way.
Okay, sir. So the question goes like this: let P not equal to 0 be a 3 cross 3 real matrix.
Okay, wait. Let me write it here. Yeah, P not equal to 0 be a real matrix. Okay.
3 cross 3 real matrix.
Hmm.
There exist two linearly independent vectors, x and y.
There exist two linearly independent vectors, x and y. Okay.
Such that Px is equal to 0.
Px equal to 0.
And Py equals to 0.
Okay.
Then dimension of range space of P is.
Okay, we are yet to discuss this. Are you from EC?
No, sir, mechanical.
You don't have this in your GATE syllabus at all.
Okay.
Okay, only EC people have this.
Okay.
Only EC students have this. This is under the topic vector calculus, not vector calculus, vector spaces.
Okay.
Only EC people have this. So tomorrow at the end, right, the last topic would be vector spaces. So if you don't have in the syllabus, so you can skip. Only EC people will go through this.
Sir, how to join your Telegram channel?
See, there is no my Telegram. There is AS Telegram, AS Technical, AS. You are from mechanical, na? AS Mechanical group is there.
Okay, sir.
What I'll do is I'll post the links in the answer box now.
Okay.
You click those and you can directly join.
Okay.
Do you have a Telegram account?
Yes, sir, I have Telegram.
Just a moment. Give me 1 minute time. Whatever Arul has asked, that is actually for EC. He doesn't have that. Okay. So I'm just typing the Telegram channels there. You please check it. Arul, see, did you get any links there? Check it.
Yes, sir. I got a link.
Bindu Priya, in the question and answer box, can you please tell me, did you get any links? Someone please reply me, yaar.
Yes, sir, we got a link.
Yes, sir, we got the links.
Vaishnavi?
Yes, sir, I got it.
Hello?
Yes, sir.
Hello?
Hello, sir.
Hello? Why the voice is not audible? Hello?
Hello, sir.
Ashwin, can you hear me?
Yes, sir. Yes, sir. I can hear you, sir. Hello, sir.
Utkarsh?
Yes, sir. So am I audible?
What happened?
Hello.
Utkarsh?
Yes, sir. Am I audible?
Now you are audible actually.
Okay.
Is my voice clear?
A little bit distortion is there, but it's bearable. Like we can hear properly.
Yeah, okay. So I'll just continue. Maybe my Bluetooth charging is over.
Sir, can you speak a bit loudly? Not much, but just a bit.
Just a second. I'm just connecting to my Bluetooth again.
Okay, sure.
Yeah, Utkarsh, can you hear me?
Yes, sir. Now you're clear. Hello.
Yeah, is it now? Is the voice improved?
Yes, sir.
Yeah. So I shared some links. Can you see in the question and answer box?
Yes, sir. The links are visible.
Yeah, visible. So you people have to click those links, join the respective groups. I will make sure the notes is uploaded as soon as possible. The question that Arul has posted is only for ECE students. ECE students, tomorrow I'll talk about vector spaces. I'll talk about dimension, basis. After that, you people have to solve this. Okay. Vaishnavi, what is your doubt?
Hello, sir.
Yes, what is your doubt?
Yes, sir. I have one question.
Yes, your doubt.
If the system of equations x plus 4ay plus az equals to 0, x plus 3by plus bz equals to 0, and x plus
once again you give me the equations x plus
4ay plus az equals to 0, x plus 3by plus bz equals to 0, and x plus 2cy plus cz equals to 0.
Now you will say, for the system to have non-trivial solution, what's the condition among ABC?
Yes, sir.
Okay, so we will talk about this tomorrow. If you remember, I said system of equations I have solved using only row echelon form.
Yes, sir.
I can also use determinants to solve that. Yesterday in the class I said.
Yes.
So once I complete determinants, I'll teach you how to deal with this this kind of problems. So in fact, if you look at the next problem, that actually is about this. Okay.
Okay, sir.
So like because of the time constraint, I could not take that problem.
Okay, sir.
So I will have a discussion on this tomorrow.
Okay, sir. One more. Sir, I am not able to get the notes.
See, notes has been uploaded in the student portal. Okay, what happened was yesterday night only I've uploaded, but because of some technical issue, like another person has to publish it. That means give the permission. Earlier, what happened was the faculty has, the faculty himself like had that right to publish, but now they have removed that. So someone else has to give the permission. Because of that, it got delayed.
Okay,
so
sir.
Today, I'll ask, it will take some time. So I have to convert that to PDF and upload. I'll ask the manager to upload it as soon as possible. So at most by tomorrow morning, it would be uploaded, but I'll make sure it is uploaded by today night. Some of the students have already downloaded yesterday notes from the students portal. Please check that.
Yes, I checked it, but I was unable to download it. So.
But others are able to download it.
Okay, sir. I will recheck it.
Right. If you have any problem, you can mention that in our group.
Okay,
which
sir.
Group A is non-technical group or A is technical group. There are some people. See, I'll tell you, technical doubts, we will help you. Non-technical, like downloading the notes, you need to contact managers only.
Okay, sir.
Okay. Any other doubt you have?
No, sir. No, sir. Thank you, sir.
Okay. Bindu Priya, what is your doubt? Mukesh, what is your doubt?
Hello, sir.
Yes, what is your doubt?
Sir, while converting the given matrix into a row echelon form, when we are changing the row interchangeability, na, sir, after performing two operations like two steps, we can interchange the rows again.
You have interchanged R1 with R3, let's say.
Okay.
And after some time, you want to interchange R2 with R3, you can do that, no problem.
No issues with solution, sir.
No issues with the solution.
Okay, sir. Thank you, sir.
Yeah. Mrutyunjay Dubey.
Yes, sir. So my doubt is, so page number 89F. So here you took that A is the singular matrix. So why did you just consider the A as the singular matrix?
See, there is no condition that it has to be singular or non-singular. What I have done is I have make sure that it's a symmetric matrix. That's it.
So we can take any other example as a.
Yeah, you can try it. Usually AB, see, in matrices, AB need not be equal to BA.
Okay, sir. Thank you, sir.
Yes.
Sir, I wanted to ask that after these two classes, can we practice from some sources or the booklet, whichever is given to us?
See, the authentic sources are the textbook. There are example solved problems as well as unsolved problems with the key. That's the first source. Second source is you can, once you complete this course, once you solve the textbook problems, you can directly solve the gate problems.
Okay, sir.
You want some more practice, go for workbook.
Yes.
You want more practice, go for mock exams. Okay?
Yes, sir.
Don't do other than this. This is enough, especially for engineering mathematics.
Yes, sir. And sir, I'm right now in second year. I'll be giving my final exam. So, am I eligible to appear in GATE in the third year?
Yes, the third year students are also eligible to write.
Okay, sir. Thank you, sir.
Sumit.
Hello.
Yes, what is your doubt?
Yes, sir. In 67F. In 67F. Yes, sir. I am not able to understand the thing with the principal diagonal plus above.
I'm just asking. Okay, how many principal diagonal elements are there?
Sir, in n cross n, there would be n principal diagonal elements.
How many elements are above the principal diagonal?
That would be the n square minus n by 2.
Now, tell me how many elements are principal diagonal, all, comma, the ones which are above the principal diagonal. Count the principal diagonal and the above the principal diagonal elements. How many it would be in number?
That is the addition, but why did we do that?
Because those elements can be like, I mean, you can actually put this elements, like Q elements are there. Now you can place those elements there. You want to create symmetric matrices, correct?
Yes.
See here. There is a pen. Look at this example. Look at this example here. Did you put A here?
Yes.
Did you put B here?
Yes, yes.
You put B here?
Yeah.
You put C here, na? Yes?
Yes.
Now, in this example, you cannot put A, B, C. There are some elements given to you, 0, 1, so on, Q minus 1. How many are there?
Total Q number of elements.
Only these elements you can put. Okay, that means this can be filled in how many ways?
In Q number of ways.
This is also in Q ways. This is also in Q ways. So that's how this question is solved. You still have a doubt?
Okay, in 104, page number 104.
Okay.
In 104, yeah, yes, why did we take the 3x3 minor matrices like that?
Because if you look at the definition of rank, what is this saying? Can you please read the third point?
Rank denotes the size of the largest non-zero minor of A.
So I need to first focus on the largest in terms of size, the largest minors.
Okay.
So that's the reason why I first looked at 3x3 minors.
Okay. अच्छा 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 okay okay समझ गया.
But all of them turned out to be 0.
Yeah.
My focus will now shift on the next
Next,
largest
yes,
possible minus.
Yes, the largest possible minus, that would be the number of.
Yeah. Let me go to the another student, Dinesh Krishna.
Hello.
What is your doubt?
Yes, sir. Sir, in the page 104.
Same page, okay.
Sir, did the rank of A will be same for using determinants and or non-echelon form, pro-echelon form? Sorry.
See, once again, you tell me clearly what is your doubt.
Sir,
You want to use row echelon form in this?
Yes, sir.
If you use the row echelon form, even then you get the answer as 2 only.
Okay, so no, the question is use determinants to compute the rank of A. The question is that, right? So
yeah, the question is to use determinants concept to find the rank here. That's why I've used that.
So if we use the other than using determinant, if we use the rank of A by using row echelon form, then rank will be same, no?
Yes, same. There is no doubt in it.
Yes, okay.
Any other doubt?
No, nothing.
Okay. Akshaya. Akshaya, what is your doubt? Sai Kalyan, what is your doubt?
Hello. Sir, am I audible?
Yes.
Yes, sir. Page number 66, sir.
What is your doubt?
Sir, in this, can we say a null matrix is also a symmetric matrix?
Yes.
I mean, okay, sir. Okay.
Null matrix is not only symmetric, it is also skew symmetric.
I mean, how it will be a skew symmetric?
Check it. You take the
minus,
transpose minus, you put whatever you said is correct. Null matrix is symmetric matrix.
Yes, and another one, sir, which was in yesterday's class regarding echelon form, which you said 4 equations, 5 unknowns, which is there earlier. Regarding that, I have just one doubt, sir. In that.
What is your doubt? This problem?
Yes, sir. Can you open the echelon form in this?
This one?
Yes, sir. After interchanging R3 and R4, for example, 3 was there in the third row, second column, sir. 3
was there in?
Third row, second column.
This here?
Here. And in the last row, can we keep in the fourth row, fourth column? If you keep any element there.
Here?
No, fourth row, fourth column, sir.
Okay,
somewhere in the beyond before that. Is this in echelon form?
Okay, I'll copy whatever you are saying.
Yeah, okay.
Okay. Yeah. Give me the changes now.
3, which was there in the third row, replace it in the third row, second column.
Third row, second column. This one?
Yeah. No, sir. After that.
This one?
This
is third row, third column, na? You want me to
put
here?
No, sir. No. Third row, second column is
there. Okay. Here you want me to put 3?
Yes, sir.
Okay. Next.
And in the fourth row, fourth column, just keep 1.
Okay. Now you want to check whether this is in row echelon form or not?
Yes, sir. I just want
this is not in row echelon form. First, this should go up.
Okay.
Here, what are you supposed to do is R3 should be interchanged with R2 first of all.
Okay, it has to come only from left to right, from the top left to top below right, like that. It has to come.
Yes.
Okay.
And also
Oh.
here also you have to go for an interchange like
R4 to R3.
yeah.
Oh, no, sir, R4. No, it's okay. It's
First of
okay.
all, see here, you can't decide the next step. First, what you have to do is interchange R3 and R2.
Okay.
So this will go here and this will come here. And then
And
again,
it
go
will be
ahead,
fine, sir.
with, yeah. So this is not in row echelon form. Is that okay?
Okay. Only it has to come from top left to bottom right.
Yes. So it's like
Okay.
you'll first eliminate x1, x2, so on, xn.
Okay, sir. Okay. Thank you, sir.
Yeah.
Sir, in the same question, sir, sorry to disturb.
Yeah, who is this?
Sir, yes. Sir, in that same question, sir, you told the first non-zero element of the respective rows below that all have to be zero. Sir, it's
Yes.
satisfying that condition, I suppose.
See here, below this you have all zeros. Below this, first of all, at the same time, this must also be zero actually. Hello?
Yes, sir.
This is not in row echelon form. You have to like make sure that this is also zero.
So means if the third column of the second row has the first non-zero value, then in the third row,
See,
all
my
elements to the left of
intention
that
is-
would be zero.
My intention is like this is pivot element, na? If first of all, this is not in row echelon form, so you need to do few more operations actually. This is not in row echelon form, right?
Sir, actually, according to the previous conditions that you told, I suppose this should be in row echelon form, but because all the first non-zero elements.
The way I explained you is like, if this was x1, this is the variable x1, the coefficient of x1.
Yes, sir.
You have to eliminate x1 from all this, na?
Yes, sir.
Okay. Here, x2 coefficient is appearing, which is wrong.
Yes, sir.
So this should come up actually. Here, x2 coefficient is 0. Here, so this should come up. That's how I taught you. Hello?
Okay, sir. Yes, sir. Sir, if you could explain it a bit clearly.
Bit clearly means, see here, the way we discussed about this is like A, this is like B. We
Yes,
first start with eliminating x1 from the remaining equations.
Yes, sir.
Next, x2 from the remaining equations.
Yes, sir, with the help of second row.
So, but here there is 0, na?
Okay.
There is 0 here. So you have to bring this here and then eliminate the ones which are below it.
Yes, sir.
Is that clear?
Yes, sir.
So that's how this progresses. Hello?
Sir, it's clear.
Yeah. The last doubt, Hari.
Yes, sir.
Yes, Hari.
Sir, page number 89, sir.
Yes.
In this, I understand the solution. I went in different way.
Okay.
I will tell you, sir. Can
Yeah,
you
yeah.
write?
Okay, I'll write. Just a minute. Wait a minute. My screen is not responding. Yeah, can you tell me what is your doubt? This is not responding, my dear, actually.
Okay, sir. Like first we take the two matrices A and B, and A equal to A transpose, B equal to B transpose. They are the givens.
Yeah, yeah,
Then
it's now responding. Wait, it's responding.
Okay.
Suddenly it stopped. Okay. Tell me You have taken A.
equal A transpose. B equal to B transpose.
Okay.
First we take A product AB, sir.
Okay.
That is equal to A transpose into B transpose.
Okay.
That is equal to BA whole transpose.
Okay.
Is this correct, sir?
Yes, correct.
Put it as equation 1, sir.
Okay.
Next we take BS.
Okay.
This
This
is
you
equal
can
to
write
B.
as AB whole transpose.
Yes, sir. We take
I'll
BA
put-
this 2, substitute 2 in 1.
And then you'll get again AB only. AB equal to AB. What is the enjoyment? Nothing, na?
Okay. We should make AB equal to BA.
Equal to BA.
Sir. Okay, got it. And the next problem, sir, after page number 89.
Page number 89, many people have a doubt actually. Okay.
After this, next problem.
Okay.
This one, we'll get a matrix which is symmetric, right, sir?
Yes.
In that determinant of it, okay. Once can you write the matrix, sir? Like diagonal elements will be, principal diagonal elements will be n minus 1.
N minus 1.
Other elements will be minus 1.
What you can do is you can actually go for something like R1 is R1 plus R2 like that. Like
yes,
that
sir.
Also you can solve. You can solve it.
Then determinant
Nice.
will become 0 maybe.
No, it won't become 0. Why it will become 0? Very nice approach you have actually highlighted. Shall we take a 3 cross 3 matrix?
Okay, sir.
Or n cross. We will do it n cross n.
Yes, sir. I done it. I thought of n cross.
N minus 1. N minus 1. N minus 1. Correct? Here minus 1, minus 1, all minus 1s. Okay.
Yes,
So I just want to do an operation like this. R1 is R1 plus R2 plus so on Rn. Right?
Yes.
What could be the first row elements?
All 0, I think.
No.
Like n minus 1, minus 1s will be.
N minus 1 plus minus 1, na?
No, sir. Like minus 1 into n minus 1 times. There are n minus 1 minus 1s.
N minus 1 plus
minus 1. So on, it will be n minus 1 times.
So when you add all of them, you get
0. And minus of n minus 1, that will be cancelled.
Wait. No, wait. N minus 1 times minus 1.
That will be 0.
Oh.
So Telugu వచ్చింది సార్.
తెలుగు వచ్చు, నువ్వు చెప్తుంది అర్థమవుతుంది. ఒక్క నిమిషం ఉండే, ఎక్కడో తప్పు చేస్తున్నాము. పేజ్ నెంబర్ 90 కదా నీ ప్రాబ్లమ్?
సార్ తప్పు సార్, సారీ తప్పే సార్. ఎందుకంటే ఆర్డర్ n minus 1 నేను n అనుకున్నాను.
ఆర్డర్ n minus 1 కరెక్ట్. డిఫరెంట్ వాల్యూస్ వస్తాయి. నైస్. నువ్వే నన్ను రాంగ్ డైరెక్షన్ లో తీసుకెళ్ళి మళ్ళీ కరెక్ట్ డైరెక్షన్ లో తీసుకొచ్చావు. ఓకే, నెక్స్ట్ డౌట్ ఏంటి?
104. అది డైరెక్ట్ గా ఇక్కడ
10 తర్వాత after 10 the session will automatically end. Okay, make sure you ask doubt because class is till 9 means only 1 hour they'll allow for doubt session. Okay, please keep that in mind. Not only this class, any class from here onwards.
ఇదే లాస్ట్ డౌట్ సార్.
ఎన్ని అడగండి కానీ 10 వరకే ఉంటుంది. తర్వాత ఆటోమేటిక్ it will get automatically disconnected. Don't feel like faculty is ending the session. They have designed it in such a way that after 10 the session will end automatically.
Got it.
Yeah.
ఇక్కడ రో ఆపరేషన్స్ చేయొచ్చు కదా సార్ ఇక్కడ?
Which one? You can do row operations, but the question is I want to explain you the meaning of rank using minors.
Okay. అంటే సింపుల్ గా అయిపోద్ది కదా?
సింపుల్ గా అయిపోతుంది, నేను కాదనలేదు. ఇప్పుడు నెక్స్ట్ ప్రాబ్లమ్ లో ర్యాంక్ గురించి అడిగితే నేను అలానే చేసింది. ఇక్కడ ఎలా చేసాము? రో ఆపరేషన్సే కదా. Clearly in the question they have specified use determinants, and also I wanted to highlight this particular point, third point.
అదే సార్.
So for that I have used determinants. At that, while explaining also I said if you get a question on rank, use row echelon form only. Any other doubt?
No. Yes.
Okay. Yashwant
Can you hear me, sir?
Yes, yes.
Sir, page number 113. Sir, in that, if we, after interchanging the row 3 and row 2, can we say it's in a row echelon form?
No, because let me interchange that. 1, 2, 1, 3, 3, 5, 0, 3, 0, 0, 3, 3, 0, 0, minus 2, minus 2, minus 2, minus 4, 0, 0, 1, 0, 0, 0. This is where we are, correct?
Sir, in the last row, it will be after in the second minus 2, sir. The one will be in the second minus 2.
Got it. Yeah, now this is in row echelon form.
Okay.
Any other doubt you have?
Sir, you gave us one problem, sir.
When?
In the starting of the class to
Today?
check the determinants to that problem.
Did you solve that, or you want me to explain?
I want you to explain, sir. I received some other answers.
Okay, see, I'll upload that second procedure. I understood you're talking about this problem, correct? Are you talking about
this one, sir? Before this, you asked many people to verify whether it's correct or not.
Which one? Which one? Give me some more. Give me some more. Anything related to the question? I'll open that. You write the page numbers. How many times I shouted? Write the page numbers. Give me some clue. Means something about that question. Yeah, I'll open it.
That's the question you copied the coefficient factor and used.
Okay. Is it regarding A inverse?
Otherwise, sir, otherwise I will ask the doubt tomorrow evening.
No, you can ask me. Is it related to this question? Check it.
This coefficient matrix you took from one question, sir. That question.
Okay, I'll upload the notes, go through it, and you can ask me tomorrow.
Okay, sir. So tomorrow the class will be from 4 to 9. Okay.
Yes, yes. Tomorrow it's from 4 to 9.
Okay, sir.
Okay, everyone, please be aware of that. Tomorrow class is from 4 to 9. I have already confirmed this.
Okay, sir.
Okay.
Thank you, sir.
Yeah. I'm ending the session. Tomorrow we will meet, go through the homework problems.